So good morning, participants. A very warm good morning to all and all. So today, as the final day of International Workshop on Computational Intelligence 2023. Uh, so on behalf of Amrita, I welcome you all for the final day session. So today we have a Maxwell Senior Engineer, Dr. Debanand Singdeo. So I will read a brief profile of Devanand. So his PhD works as senior engineer in education team at MathWorks India Private Limited, Bangalore. In this role, he collaborates with academic institutions for effective utilization of MathWorks resources in education and research in areas of electrification, data science, and IoT. And he has an interdisciplinary background with bachelor's degree in physics from Vishwabharati, Shantiniketan, followed by MSc PhD degree from Department of Energy and Science and Engineering, IIT Bombay. In previous roles, he has worked as a postdoctoral fellow in the Department of Energy Technology, Aalborg University, Denmark, where he was part of an industry academia consortium that focused on fuel cell commercialization. He has also taught courses and simulation lab on energy systems as DST in spare faculty at Tezpur University, Assam. So these are the experience of Debanand. So I welcome you, Dr. Debanand, to our humble platform, and you can take over from there. Yeah, thank you.
Okay, sure. Sure. Very quickly, I hope all of you can hear me clearly, and you can also see my screen.
Yes, sir.
Okay. Okay, sure. Yeah. So today we will be talking about a very interesting sort of an approach. So first of all, thank you to Dr. Rahul for allowing us this opportunity to come here and interact with all of you. Yeah. So the topic I have chosen is about data-centric AI. So we will come to see very soon what is this data-centric AI approach and why this could be useful for signal processing applications. All right. So we will be looking at some very interesting examples that will give you a good idea about what is this thing called data-centric AI and how you can implement it by using MATLAB and Simulink at your end. So as Sun mentioned, I'm Dr. Debanand Singdeo, and I am part of the education team at MathWorks. So we are a team based in around the 4 offices of MathWorks, and each of us have a specific sort of an expertise. We very closely work with academic institutions, both in the area of supporting teaching as well as supporting research. Okay. So today I will go through a very brief sort of an introduction about uh, who we are, and then I will go over to AI, talking about what MathWorks has to offer overall in terms of support for AI related projects. And then we will talk about your challenges also. So when you're working in the AI domain, what sort of challenges do you face? Among the challenges specifically, I will look at one specific approach and try to see what sort of challenges it can solve. So then I will translate over to what is data-centric AI. And then I will pick up examples which are relevant to showcase the advantages of going for data-centric AI. And then after examples, we will recapitulate our learnings and then look at resources that can help us do a bit of self-learning from our side. All right. And as we go along, I think would be good to have things interactive. So I will be asking a few things from your side and looking at your responses. Also, please feel free to mention your challenges, things you are working on, and any sort of queries that you have with respect to the topic. And I think that would have a very useful sort of a thing for all of us, a useful learning session for all of us. Okay. Yeah. So at many places, we are mostly known as the company of MATLAB. So people recognize by our products MATLAB and Simulink. So that actually showcases how our flagship products have been instrumental in terms of uh, applications at many different places, both in teaching and research. So when we look at MATLAB, it's the programming environment. So in case of MATLAB, we can design algorithm, work with data analysis, visualization, and do numeric computing. So today we are going to largely use MATLAB as the programming environment for whichever examples that we are going to go through. There is also something known as Simulink. Simulink is the platform which actually is used for simulating and testing dynamic systems. Okay. And MATLAB and Simulink are very, it's not like it's totally different. So Simulink is based on top of MATLAB. So if you are able to build an algorithm in MATLAB, you can actually call it in Simulink and then create your larger engineering system in Simulink and simulate and test it out. Okay. So this is something that we largely see companies do when they are working with large engineering systems or engineering systems specifically for incorporating or integrating AI. And then there are numerous other toolboxes which are there specifically to help make your tasks go faster. So these toolboxes have very useful utilities that can allow you to design your algorithms or create your entire model in a very short period of time. Right. So this was about MATLAB and Simulink and where are these used? So I have just listed here some of our key customers and industries. So we can see that MathWorks has a footprint across diverse industries, going from aerospace, automotive, biological sciences, energy production. So this is an engineering, this is a particular domain I have been very closely associated with. And then you can see medical devices, semiconductors, software, internet. So large number of industries. Aerospace and automotive actually are our key customers. So a large amount of user base actually comes from these two key industries, aerospace and automotive. So in aerospace, they use it to design the avionics for the flight systems. And in automotive, MathWorks is largely used when it comes to design of control systems, generating the code that runs on ECU in the area of ADAS, right? So this is how it is. Okay. Now, coming over to the AI part. So if you look at how our AI journey has been, so since 2016, when we actually started with coming up with different updates, we have come along a long way. You can see till about 2021, I have listed some of the important features that came in. So some of the ones that I've listed here are in the broader area of deep learning. Okay. So in the area of deep learning, if you can see, we have come up with different algorithms, a lot of examples you can see here. So I think close to 300 examples have come up. And then we also have very useful apps. So in 2018, we introduced apps which allow you to work with data, label the data. Then in around 2019, we can see that we have come with apps for labeling different signals, which could be very useful for signal processing applications. And then in 2020, you can see there was a lot of focus also in the area of quantization, how we can make the models more sort of efficient in terms of memory, how we can introduce explainability within our AI models. So these were some of the things that came up. Yeah. And with all the features, we have a number of examples that actually showcase how you can use these features. So for users, it's very clear that you can actually use these examples to learn about our workflows, and then you can use it very effectively. Right. Okay. Okay. So now I will sort of transition over to the challenges part of things. Okay. So I have a plot here. So has anyone seen this plot before? So to give context, this is a plot that we sort of see in academia. Okay. And this is sort of the plot which industries can relate with. Has anyone seen this plot before? I was just checking, like, are you able to send your responses across? Okay. I'll just quickly check if you are able to send your responses in the chat. Let me just quickly check that. Okay, I can see that there are some responses in the chat. Okay, so I see one yes and three no. Okay, I think that's fine. Uh, Thanks for putting in your inputs. That's totally fine. Yeah. So if you look at this particular plot, so it came from uh, uh, Andrei Karpathy, so who is from Tesla. And what they have come to sort of acknowledge is that in case of industries, they actually spend a lot of time working with the data sets that they have at their end, right? So Tesla actually collects a lot of data. So they have a lot of data, and to come up with better sort of performance, they look at how they can actually make this data much more useful. So they spend a lot of effort just working on the data pre-processing part, making it more effective, leveling, those sort of things. While in academia, if you see, a lot of time we actually spend working on the modeling aspect of things, right? So data set remains a smaller challenge compared to working with the model aspect of things. And this is not something I would say which is uncommon. So from MathWorks side, we actually go and visit different academic institutions, and we see the same sort of response that a lot of researchers actually spend a lot of time working with the model compared to working with the data set. Do you know the reason why this is? So this is a trend, what I'm saying, but is there a specific reason for that? So the reason that we have heard of is that specifically when it comes to industries, they are actively collecting the data, right? So because of that, they have to actually work with the data and try to sort of spend time to effectively do the pre-processing part. While in academia, what we have seen is that a lot of researchers have access to data sets collated by other professional organizations. So in that case, because the data set is readily there, they directly get access to that, and then they focus more on the model aspect of things. Okay. But when the same PhD student would translate to industry, so this is the scenario that they are going to sort of encounter. Okay, so they have to work a lot with the data compared to the time they spent on actually the model aspect of things. Okay. So this is not something uncommon. So this is something that we see a lot. And another important thing that I would just like to stress before going ahead is that people are also talking about this. So professionals who are at the forefront of AI are also mentioning the similar sort of thing. Okay. So all of us, I believe, know Andrew Ng. So chances are that we might have seen some of his courses, right? He has a very nice way of teaching things. So what Andrew also says is that it's time for us to look at smart-sized data-centric solutions to big issues. Okay. So this is the term that he mentioned. So this is a particular interview that came up in IEEE. So unbegun AI. Okay. Unbegun AI. So he says that it's time for smart-sized data-centric solutions to big issues rather than looking at big models or more complicated models. We have to look at how we can come up with better ways of looking at data, and that would effectively lead to smart-sized AI solutions. Right? Yeah. Yeah. So this is the key term that he has mentioned. Yeah. So now uh, I will put in context like uh, uh, another factor that is there. Okay. So if we look at most of the existing AI resources, chances are that you will see that it typically falls into a particular category. Okay. So there in particular applications, you get actually a lot of data. Okay, so when we are talking about that, we need to focus on data. We have to look at where we are getting the data from. Okay, so here there is the problem that now we are looking at how we can sort of come with data centric solutions. But then where are we having all the data from? So if you look at some of these applications, so these are some of the popular applications which have now existing solutions from AI. So it's like autonomous driving, any sort of language models which are there, computer vision, speech recognition. In each of this field, you'll see that a good amount of data sets actually sort of is already there. Okay. The reason is because in the evolution of AI, specifically, there are a few organizations or few applications we have which have actually accumulated all this lot of data. Okay. So in each of these applications, there have been lot of data, and there are a few big companies also which have worked on these applications, and they were also able to collect large amount of data. So if you're working with any of these domains, you can relate to it that you have a large amount of data available at your end, right? uh, Anybody working with this sort of domains? Any of these domains, these four domains?
Yes.
Yes, right. Okay. So here you will not have a lot of challenge looking at accessing data, but mainly when it comes to data, the challenge you will find when it comes to engineering applications. Okay. So if you're working in these areas, okay, uh, uh, we have users working in the area of vibrations, seismic analysis, predictive maintenance, digital health from the medical industry, as well as machine health. If you are working in these areas, chances are that you cannot count on many AI resources. Okay. So this is a problem that many of the companies actually face who are working in these areas. They do not have a very sort of standard data sets which they can work on. So they are actually spending a lot of time uh, uh, just uh, so they have actually started collecting the data, but they have to actually spend a lot of time to come up with newer groups. So people with the skills to actually understand the particular data and then build AI models based on the data. So they spend a lot of time on this. So this is a challenge that they have. Also, in these areas, you also do not have readily available AI models. So they also spend a lot of time finding out what sort of AI models would be appropriate. So uh, this is one challenge that we see when it comes to industries. And definitely they are actually looking at AI adoption. So we hear about many industries where they actually want to incorporate AI, but the challenge that they have is that they do not have the capacity or they do not have people with skill sets who can work with this sort of data. Okay, and then they're actually getting this data, but in this case, the data is also quite raw in nature. So they have to look at how they can use the data in a better way. All right. Yeah. Okay. Moving ahead, let's see what's now your AI related challenge. So I have sort of bucketed things, but if you have anything apart from what you see here, that is also fine. So the first bucket that I have is okay. Okay. So let me know which are the challenges that you have. So one challenge I mentioned from my side is that access to data, and the second challenge might be uh, uh, not really having the idea to how you actually can work with the data in a better way. Okay, so first data access, and then once you have data access, how you can work better with the data. So this could be one of the challenges. Okay, so let's hear from you. What sort of challenges do you have when it comes to your AI model? Yeah, thanks. I see some answers. So, yeah. So as Pooja correctly mentioned, so in many companies, they're also working on real-time data compared to that in academia. Yeah, that's a very interesting point. And I totally agree to that. Language modeling. Okay. How to merge data to model. Okay. So you might have some sort of model at your end. How can you merge data to model? I mean, or okay. I might have to look at a few more details at that. Hypertuning. Definitely, that is something that actually comes when you actually go to training this particular sort of models, how you can actually tune the hyperparameters. So even in terms of answers, if I see many of you mentioned that the challenge comes from the model part, and then we have some of you mentioning that it is related to also the data aspect of things, right? So it's good to see this sort of response. So thanks for putting in your response. Okay. So some of the things I think broadly now, okay, so we also have I think Mr. Shambhu Chaudhary, who's working with three-phase grid, and he wants to build a model for inverter. Okay. So I think this is more like an engineering problem that you have. Okay. So are you planning to use AI for that? So do let me know. Okay. Okay, that sounds great. So here you have also used an ANN before. Yeah. Yeah. So we have good examples in this area also. So electrification also is I would say it's a very interesting area. We see a lot of people actually working with trying to see how you can use AI effectively here. So people use it in the event of predicting what amount of load and all they would be sort of expecting at a given point in time, and then how to effectively use the resources at one's end to respond to that sort of a load. Yeah. Okay. So thanks for the responses. That's very helpful to see the interactiveness. Okay. Okay. Yeah. So coming to the eventually how we can tackle this sort of thing is that we will sort of look at an example. Okay, so what we will do is that we will look at an example to understand what is this data centric AI approach, and then in this data centric AI approach, we will be using pre-trained AI models. Okay. So although I will talk about how you can create models from scratch, we will look at how you can actually use pre-trained AI models and use them to do some sort of transfer learning. When it comes to data-centric AI, so one very important thing is that the focus should be on how I can use the data effectively. So to do that, I will take the data that is there at my hand and I will do feature extraction. So when I do feature extraction from the data, I don't have to use a very complicated AI model. So what I will do is that I will use simpler model, or you can think of also like smaller sort of AI model, and that should give me sufficient accuracy compared with a more complicated model. And finally, if we have better signal data sets that is already there, if I have these particular point, better data sets, definitely I can have better sort of accuracy. So the data set could be real, or in some case, we can also do with simulated data sets. Okay. So let's say I'm creating an algorithm for a particular application, and I do not have any access to real data set. In that case, I can take recourse to simulations. Like the application server saying, let's say I am working with some sort of grid and I don't have effectively good data set. I can simulate and then from the simulations, I can get some sort of data sets and use that to train my AI model. So that should also be possible. Yeah. So let's look at the part of how we can do this AI-driven system design. So there are broadly 4 steps that we need to go with. The first step is the data preparation step. So in this case, what we need to do is first get access to the data that we are working with. Take the data. If the data is not in a proper form, then we need to sort of clean it. And then we can do some sort of feature extraction with that particular data. Definitely, this is the area where we also need some domain knowledge. So if you have domain knowledge, you can actually come up with good sort of features. There is also possible that if you don't have very good or if you don't have data at your hand, you can go for simulation generated data sets. From the data, we will be building the model. So in our case, what we are going to look at is that there are a couple of approaches that you can take based on your own preference. So we will look at that. If you have hardware at your end, specifically for training models, so let's say if you have access to GPUs, you can very easily use those GPUs to have accelerated training. What is also possible in case of MATLAB now is that we have interoperability. So you can actually bring in models from different frameworks like Caffe, PyTorch, and then you can sort of look at the models in detail in MATLAB, and then you can do the training and deployment part. That should also be possible. Third aspect comes to once we have developed our model, how can we integrate it with different systems? So if you have an engineering system, you have to integrate with that. If you have any sort of enterprise system, so if you are a user of let's say who is working on any sort of business system, then you need to be able to integrate it to that business system. And then if you have built a system, chances are that it's good that you can do a system simulation and carry out verification and validation. Finally, deployment plays a very important role in the end-to-end workflow. So starting from data to the deployment is a very effective thing to learn for. So once you've created your model, you need to actually deploy it to an embedded device. If you have an application like that. So if you're planning to deploy it to an edge device, you can actually do that. Or you can also integrate with enterprise system as well as the cloud. Now, this is not a linear sort of a system to go with that you start with data and end with deployment. In many cases, this can also be an iterative process. Okay, so after doing one round, chances are that you might need to go through these steps once more. There could be some sort of optimization we can do, or there could be some sort of improvement we can bring if we are using this sort of an iterative process. Okay, so this is the workflow aspect of thing, how you can start with data and go towards deployment. The reason I showed this now is that we are going to look at this with the help of an example. Okay, so we'll take an example and go through these steps so that we have a better understanding of what are the things that uh, come up when you actually go through this sort of a workflow. Okay, so let's go to the example. So the first example that I have here, yeah. So this is on speech command recognition. Okay. So I'm showing the demonstration with all the detailed steps. If you'd like to try this out, you can actually look at the example. We have this on our website. It's very easy to gain access to it. And then you can follow the steps that I'm actually showing you. Okay. So this example, I am not going to run from my MATLAB. This is something I have recorded at my end. Okay. So I have two examples. The first one is recorded. The second one we will do in a hands-on approach. So that's how I have planned this thing. Okay? So in speech command recognition, what I have is that I have audio signals. So these are audio speech signals. So a person speaks a particular word, and then we should be able to sort of predict what word he is speaking. So this is our end goal. Okay. So the end goal is that a person is speaking a word. We should be able to identify what word he is speaking from our model. So we can see that he's speaking sort of single sort of an word, and we are also able to see the audio signature of those words, right? So this is the audio signature, and below, if you see, this is a spectral representation of that particular signal, right? So I will play it once again. These are the labels we want to predict. Once we have trained our model, we should be able to predict this. All right. So where do we start? The first state of starting would be access to data set. Okay, so the data set that we have used in this particular example is okay. So firstly, this is the example that we have used. So if you want to try it out, you can actually go to the MathWorks web page. Look for this particular example, speech command recognition using deep learning. If you just search it here, you will actually find this particular example. And you can try it directly in MATLAB by clicking this particular option. It will open up for you. So here, the data set is from Google, right? So Google actually has an AI blog where they have listed what this all data set is all about. So in this case, all you need to do is uh, get access this particular data set, download it, and then you can use it at their end. Okay. If you like to read more about this particular data set, you can actually look at a publication also, which they have related to this. So first step in our case is what we will do is that we will access the data. So if you want to download the data, uh, you will have a link like that. You can actually go and download that particular data. Okay. So once you download the data, you will have a folder where you'd have multiple of these categories. Okay. So if with respect to each category, you will have audio samples. I think each folder has about 2,400 audio recordings. And some of them are also about people who are speaking particular words. So people from different backgrounds are speaking those words. And each of these lasts around 1 second. The audio samples last around 1 second. Okay. So if you look here, the first step that we're doing is getting access to that particular data set. Right. So there you can see all the folders that are there. If you want, you can just go inside and have a look. You will see that there are all these audio samples. Each one of them is around somewhere around 30 KB. Okay. So what we are going to do first is that you have such a big data set. At MATLAB, what we don't want to do is that load all of them in the memory at the same time, right? So that will sort of give freeze the computers, right? Because it can't load such a huge data in its memory. So the first thing we do is that we create something like a data folder. So here, if you see, I have a command. Uh, I have named wherever I have downloaded all the data, I have named it as data folder. Okay, so I can see which directory it is. If I want, I can go there and have a look at the data set. What I want to do is that instead of loading all this data into the computer's memory, I will create an audio data store. So here I am creating an audio data store and naming it as ADS. So whatever folder I have identified, so I can see the data folder which is there. And what I'm doing is that I'm including all the subfolders within that particular data store. I can see what file extension I have. The file extension is .wav, right? So I'm also identifying that whatever file will have an extension of .wav, that will be part of this data store. So with help of this data store, then I can actually access any of the data that I have at my end. Very similar to this, if you're working with images, you need to use image data store. So audio data store gives me access to all the audios that I have in my data set. Right? Next, yeah, so this is the audio data store part. What you can also do is that after you have created this, you will be, if you run this, so you can run this by just clicking this blue bar here. So after you run this, you will be seeing that you will have access to the file. So it has created an audio store with certain properties. And I can also look at the labels of this. Okay. What sort of labels are there? So there are lots of categorical labels which are there. I can see it just being highlighted here. Okay. Now, what I want to do is that I have so many different categorical data set. I do not want to sort of go and look at all sort of words. I want to choose words that I want to recognize. Okay. So this is a big data set. I don't want to train and come up with a model that sorts of recognizes everything. I will use my data effectively, identify what I want to do, and then based on that, work with the data set. So in this case, I want to choose words to recognize. So which are the words I want to recognize? We want to recognize words uh, uh, that are like commands. Okay. And whichever words are not commands, we will label them as unknown. Okay. So this part, what we are doing is that we are focusing on words that are like commands, and whatever words are not commands, we are labeling them as unknown. Okay. So this is the place, after you run it, you are able to see that the commands that I want to actually sort of train my model on are listed here. So what categories do I have? These are the ones: yes, no, up, down, left, right, on, off, stop, go. This is all. Okay. This is all that I want to train my model on. What I don't want to train on, so those I will just label as unknown. Okay. So how am I doing this? So what I'm doing here is that in this particular in this particular variable command, I am identifying the categorical data which I want my model to train on. Okay, and then uh, based on uh, based on this, what it will go is that it will look at my data set, and then it is going to identify if the word that it is looking at is a member of command. If yes, then we will train on that. If no, then we will point. If then we will point that data. We will label them as unknown. Okay. So here you can see we are labeling it. So this is a way of data transformation. We are labeling the data, some as commands. So if it has these words, yes, no, up, down, left, right, on, off, stop, go, we will label it as a command. If not, we will label it as an unknown, and I will not train on those. Okay. Got my point? If you have in any questions, just feel free to let me know. Okay. I hope you're clear now what we are trying to do here. So once you do this, and if you run this, what you will see is that, so okay, this is done. So once you have done this, what we want to do is that after doing this transformation, we want to have a count of how much is our data set. Okay. So here you see, I'm looking at a subset now. So if it is a command, or if it is an yeah, so if it is a command, then give me how many counts of labels I have. Okay, count each label. So then I see I am getting a table here which is giving me, based on the commands that I have chosen, how many uh, how many data sets do I have for each command. Okay, so for down I have 2359. For Go, I have 2372. So now I have a good idea of what is the actual data set on which I want to train my algorithm. Okay, I don't want to train on everything. I want to be very focused on what I train my algorithm on. Right? Okay. Good to proceed. So so now I have my signals here. What should I do now? Should I go to training? what is missing now as a point from what we have seen so far? What is missing now? I have the data here, but I haven't done any feature extraction, right? I haven't done any feature extraction. So now is the time to look at how I can do the feature extraction. Okay. So in this case, what we have done is for feature extraction, we will compute the speech spectrogram. Okay. So before going to speech spectrogram, what we have done is that we have taken the data that we have at our end. Okay.
There is a
So we
hand
have our
raise
data
actually.
as a data folder.
There is a hand raise.
Okay, okay,
Setu,
sure.
Setu, you want
Yeah,
to ask something?
yeah. Please feel free.
Setu? Yeah, I mean, may not be there. Yeah. Sorry.
Okay.
Sorry. Yeah.
No problem, no problem. I think. Yeah, feel free. Let
But
me know. I think we have
yeah,
enough time
participants,
to
please
address
don't
questions.
wait for the hand raise. You just unmute and ask directly.
Okay. Okay. I think then we can sort of proceed. So here, first, before going to the feature extraction part, here we are splitting the data into three parts. Okay. The first part is going to be the training. Second would be validation, and third would be testing. Okay. So this is the command split data. So using split data, if I directly pass it the audio data store and the folder, it will split the data into three parts. Okay. But what I want to do is that I want to actually work with the data more efficiently. So in this case, what we want to do is that we want to use the data to train a convolution neural network. And for that, what we are doing is that we will compute speech spectrogram. Okay. So, okay. So here what we have done first step, we have divided the data set into three parts. So a majority of it, 60 to 80% will be used for training. 20 to 10% will be used for validation, and around 20 to 10% will be used for testing. Okay. But before going to that, what we are doing is that we are going to calculate the speech spectrograms. So speech spectrogram means uh, we have, if you see here, there's a supporting function here called speech spectrogram. We have used this here, and it will compute the spectrogram for the training, validation, and the test data set. Okay. So we will look at what I get as an output, but here, what we are doing for each of the training, validation, and test data set, we are applying this speech spectrogram. Okay. And then just not that, we are also using a logarithmic function on top of that. So this will allow us to also have very compact sort of information within the spectrogram. Yeah. So finally, we are doing it to all the three levels. And here, this is where you can actually see the speech spectrogram function. So I have used this function called speech spectrogram. So if I look inside this function, we can see that what it does is that it will, in a loop, read in different audio, uh, the audio samples it will read. And for each of them, it will take a window and a particular length, and then it will calculate FFT with respect to it, and then give me my speech spectrogram. So however number of files I have, it will loop through all of them, read the data, and then if you see, this is the place where it is actually calculating the male spectrogram. So male spectrogram is very relevant to the data that we have at our end, which is speech data. So it is particularly used for speech data. If you have any other data at your hand, chances are that you have to use the appropriate spectrogram for that particular data. Right. So this is the part where if you see what we have done is that we have split it up around 10 times. And you can see that it is calculating the speech spectrogram and giving me the results right here. So this is the reason I had to record it, because it takes a bit of time. If you just calculate this sort of spectrogram with a normal laptop. If you have a GPU at your end, things will be different. Things will be faster, and you'll be able to see results in a shorter period of time. right? So just to show, after you run this, it will compute speech spectrogram for each data point which is there, and you can see here how many files it is processing out of the total file and shows the progress. Okay. So for training, testing, and validation, it is able to carry out the uh, uh, speech spectrogram. And I can also see how many sort of files I have at my end. Okay. So in the end, it will also plot something like this. So in this plot, what I actually have to see is that it is taking a particular audio signal like this, and the respective mel spectrogram it is plotting like this here. So this it is doing for all the audio samples that I had at my end. Okay. So some things to note is that in this case, if you look here, because we have a CNN, first thing is that a CNN will take an image as an input in many cases, right? So I am having all this in the form of images, and it will be in the form that the network will be able to take as an input in. The other thing, if you note here, is that uh, in this case, we have actually packed a lot of information within the input. So uh, it will help us in reducing the complexity of the network, which we can use to train our model, right? So this is the second thing we can actually focus on, that it is able to actually uh, capture a lot of information within this particular spectrogram. So what I have here as a plot, if you see on the x-axis, I have time, y-axis is the frequency, and the color is corresponding to the amplitude of the signals, right? So the color corresponds to the amplitude variation in the particular signal. So now the next question comes up is that now what network should we choose and how do we train that particular network? So typically the good approach here would not be actually to take a network and train it from scratch. Okay, that is possible if you are a person uh, who actually uh, comes from if you have a domain expertise in the area of deep learning. Definitely you can create a neural network from scratch. Okay, you can actually create a very good network and then you can actually train that. So it might take a bit of time also, because everything it has to learn from scratch. But alternatively, what we can do is that we can use pre-trained models also. So in case of a pre-trained model, all we need to do is that since it has already learned some of the features, all we need to do is that train it for the new tasks. And chances are that in this case, because we have existing very good neural networks, we do not need to create anything from scratch. We do not need to be an expert of deep learning to create that network. And since we are fine tuning the network weight, we can actually do it within a very short time. So training is a lot faster. But again, it depends upon your application. If you're working on something very specific, you can go for the other option also. So we will look at both of that just to get an idea that how you can create a deep neural network from scratch. And if not, if you're using transfer learning, how you can go about that too. Okay. So as of now, we will go with the transfer learning approach and we will use a trained, uh, we will use a pre-trained model to do this particular aspect of this workflow. Okay. Yeah. So there are a couple of ways we can go about it. Okay. If you look here, this is typically the command-based approach. In case of MATLAB, what you can do is that you can create the entire network based on command. So you need to know the sort of uh, the way you have to write it. So here you can see initially we have defined the class weights, the number of classes, the dropout probability, and then here we are defining the layer. So we can do it by way of command. If you're comfortable with command, this is also fine. So each layer we are defining in terms of command, there is an image input layer of a certain dimension. We have to mention the image size. We have to mention uh, what sort of layer follows it. So after the image input layer, there is a convolution 2D layer. Uh, uh, we also need to sort of define what is the size of this convolution 2D layer, what is the padding, what layer follows that. So I can see there is a batch normalization layer. So like this, by command, I can actually create the entire network. So that is one possible approach which we can take. Okay. Yeah. So we defined layers here and class weights for each layer. Yeah. The alternative approach, which is there, as I mentioned, in case of MATLAB, we have a number of apps that are there to actually make our tasks a lot easier. Okay. So the alternating thing that I can do is to use something known as a deep network designer. Okay. So deep network designer is actually a graphical tool. So in a graphical tool, what we have, instead of writing command, we will use what you see here, the input layer. So here we actually have multiple uh, uh, layers which are already defined. Graphically, we can take this layer, bring into this empty canvas here and create our own network. Okay. Yeah. So here, if you see, it's a drag and drop sort of an environment. All the different sort of layers which are typically used are listed here. Based on any use cases, you need to just go to a particular place, drag the layers that you need to actually use in your model, connect them together. Yeah. So once you've connected everything, you can actually also copy, paste, and create further bigger networks. Okay. So this would be sort of the second step. Also, in property window, you can see what each of the layers actually means. So for each layer, we can see the properties of that particular layer listed here. Once, so this is one way. So this was like creating network from scratch, right? So this is creating the network from scratch. If you are an expert in this field, if you have a good idea of how to create networks, we can follow this sort of an approach to create your own neural network. Yeah. The other way, which we were talking about, is the transfer learning way. In that case, what we do is that we create this entire sort of a, we instead of creating this entire sort of a network, we actually import it. So here, uh, instead of doing this, what we can do is that we can go to this top option. Here you can see import. So using import, you can actually go and import any sort of network that you are interested in and that you see could be useful for your application. So here you can see I've imported certain network. I can, even with that imported network, I can go and I can look at the layers which are there. So any popular model which you see is common among researchers or common among users for that particular domain, we can actually import them here and visualize how that entire network is structured. And if needed, we can make changes also. Okay. So if needed, we can make certain changes also. We can analyze whether the network that I've designed is correct, has any error or not, and what are the learnables, total learnables within that particular model. So this is the place where all the learnable parameters are sort of summarized. Okay. And once I'm happy with that, then I can go ahead and start training with that particular model. Any questions on this? Anybody already has experience with deep network designer before this particular instance? If you could put it in the chat, like, have you used deep network designer before? Or you can let us know which of the approaches that you see is easier. Okay, so it's good to see that for some of you it is new. Anyone already familiar with Deep Network Designer? Okay,
Yeah.
yeah, that's quite interesting to know. So compared to our interactions, what we have seen is that actually users who are starting out, for them, deep network design is actually quite easy to use because it's intuitive. You can actually see all the layers and you can very easily work with it with respect to. I mean, you can very easily interact with it compared to the the command-based approach. So coding, it's not easy to remember also, right? Coding syntaxes, it's not easy to remember. So rather than going by the coding way, you can actually use the deep network designer. So yeah, in a next example, actually, I will be showing you the steps. We will be actually working with a network, and then we will look at how you can actually use deep network designer with that particular network. Okay. So this is more like a sort of an overview, how the workflow is, getting an idea of the workflow, and in the next one, we will do a bit of hands-on to get more feeling with how it is actually to work with this sort of networks in the deep network designer. And you can work with any network. So whether you are working with any other model, if it is available somewhere, you can actually sort of import it and then visualize it. Not just visualize, if you need, you can replace the layers here also. Any layer that you want, you can just delete and bring in a new layer. So you can very easily work with any sort of network and customize it according to your own requirement. So you don't have to create the entire thing from scratch. Okay. Yeah. So now the part that comes up is that how do we train that? So in this one, again, because I'm mostly using the command-based approach, I'm just showing how the script is to train a network. We can do the same thing from Deep Network Designer. We will see that later. Okay. So if you look at this option here, which says train network. So here what we have done, we have used the Adam optimizer. We have decided a mini batch size of 128. The training will continue for around 25 epoch. And then the initial learning rate, if you see, it's quite small, 3 into 10 to the power minus 4. But as we go along, after about 20 epoch, we will reduce the learning rate by a factor of 10. So all the details with respect to training are mentioned here, which is, so when you train it using command, the thing you have to do is that in training options, you have to define the details of the training algorithm. So this is more like, I think of this part like an optimization that runs in the background, right? It's like it sort of optimizes and the weight and the biases in the model. So we give it an initial learning rate, uh, and then after a period of time, what we have done is that we have reduced the learning rate also by a factor of 10, so that we are able to sort of narrow down into the and have better accuracy. What we are also going to do is that we are also going to look at here, if you can see, we are going to plot the training progress. And then we also will plot with respect to the training progress at certain points in time, we will do validation. And with respect to the validation, we also want to see that validation is also sort of pointing us out that we are reaching better and better accuracy. So we will track validation also. So let's look at how this will progress. If you do not even have a GPU, it will take a bit of time. But if you have a GPU, this again is going to be faster. Okay. And then finally, uh, we will have the trained network here. Yeah. Similar thing we can do from the deep network designer. We will see this later. So deep network designer also have options here where you can bring in data and do the training. Okay, so we call it like this is a code-based approach. This is like a low-code approach is what we say. Okay, so again, plotting the training progress, and then we have sped it up. So that is the benefit of having a recording for that. We have just sped it up, and you can actually see that the accuracy is sort of rising and the loss is actually decreasing. And at certain points in time, we are doing the validation also. And we can see that we have done the completed the training. And at the end, we have reached a validation accuracy of 95.41%. And we have sort of completed the entire training, right? In this case, there was a single GPU which was being used. So this was a laptop GPU, single GPU was being used. So depending upon your computing resources, it will take a certain amount of time. In this case, the entire training took around 24 minutes of time. Okay. You can see how many iterations we were doing per epoch, around 220 iterations per epoch, and the maximum iterations were around 5,500. Okay, I don't know what this is, but it says patience is infinite. That's interesting. Yeah, any questions on this part? So you can actually do the training like this, and you will be able to sort of view the training progress also. Okay. After doing the training, you can have the trained network. So the last command, if you see here, was giving me the trained network. So the trained network, then I will take and try to identify what sort of accuracy I have with respect to my test data set. Okay. So I have a test data set. What I'm doing is that here, if you see, we have just run this part, and I can see that the training after the training error is around 3.3%. And when I'm doing testing, I'm getting an error about 5.11%, which is, I think, still fine. Not a lot of departure from the training error, right? It's about increasing by about 2%. Okay. Yeah, so here is where I'm doing a bit of classification and trying to see what is the mean training error that I have at my end. Okay. Yeah. So we are comparing them, and then we are plotting this confusion matrix. So this is known as a confusion matrix. And this gives us a very good idea with respect to the labels that which are the labels for which I am having less accuracy, or which are the labels for which perhaps I need better data. So that sort of an idea can be gained from this sort of a matrix. Y-axis represents the true class. So these are the categories. These are the, let's say, uh, the categories with respect to the true class. And this is what my model is predicting. So predicted class is listed here. Okay. Diagonal gives us an idea. So the diagonal, if you see us, it gives us an idea about in which cases it did the correct predictions. So if you see, this is yes. So I can see in 231 instances, my model was correctly able to predict yes. What are the times it made some mistake? So I can see the times it sort of made a mistake. So this is predicted, right? So in some cases, uh, uh, so the mistakes are listed mostly in the off diagonal part, right? So whatever you see off diagonal is the mistake. So I might have predicted it as yes, but the true class was in some case no, right? So in two instances, I have incorrectly predicted no as a yes. Okay. With respect to unknown data, so data which was unknown for me, I have made a mistake of around 6 times for predicting that, right? So this gives us a good idea about that. Also, we can look at with respect to specific data. So left, I can see how many times it was sort of correctly predicted, 90, close to 94%, and how many times it was incorrectly predicted, around 6%. So there is a summary of also that particular aspect also. Similar, we can look for other words also. Yeah. Yeah. Okay. So now this part is also done. Now the last part would be to take our model and then use it for, let's say, a person speaking and try to see how this particular model performs. So now it is a sort of an application that we are looking at. So real world application is something that we can actually now look at. So if you look here, these are the commands. So now I'm running this particular model in a way that uh, it is uh, it is given unknown word. So somebody is speaking a word and it is trying to identify which command it corresponds to. Okay. None commands are also listed, but we will look at which command it corresponds to. So you saw how it actually performs when it comes to the unknown. So we specifically, if it comes to unknown, we can see that it is sort of able to predict for some cases, but in some cases, like when he says the last word, it was not able to predict, right? So this is the actual sort of an app implementation part with respect to the particular example, right? Okay, so now any questions from your end? Yeah, I see some questions. So in this case, when we were doing the implementation, it was actually implemented in real time. Okay. But definitely in this case, it was not something that was implemented on any specific different hardware. This part was actually done from the same computer. Uh, but chances are that if you deploy it, if you think that there is a real hardware which is needed as a next step for deployment, so there would be an additional component that would come in. So whatever model we have created now, uh, we have to go one more additional step, take that model and convert it to code that would run for that specific hardware. Okay. So in that case, you will need to generate code for the specific hardware. So it would be one step more. I see one more question. Okay, the version of MATLAB that you're using is not easily available for research, as in the licensed version, and the student-only trial version, the functionality is limited. Okay. So for research, I would say the licensed version will actually give you all the capabilities. The only thing that you need to do is that perhaps, so in each version of MATLAB, there is some new capabilities that come in, right? So the version of MATLAB that I have as of now is 2023A. So we have 2 releases a year. So probably you have to look for the latest release. So latest release will actually have the latest sort of features. Okay. For student only, yeah. So student only, if you see the student versions of MATLAB which are there, it's mostly for learning purposes, right? So most of the things that are typically a student would need to learn about, those aspects are, I think, there. You might not have the advanced capabilities which might be useful for research. That could be there. So you could be right in that. So I think if you have the normal licensed version which is there, you should be able to use it for research, as you have mentioned. All the things should be there. Only thing that you have to be careful is that, let's say there are a number of toolboxes, right? You have license to all the toolboxes. Sometimes all you need to do is go there and install the additional toolbox that you need. Okay. Yeah. So additional toolboxes can be installed. I will show you where it is there. So let me just quickly show my MATLAB and show you where you get the additional things which are there. Yeah, we'll just open up MATLAB. Let me know if you can see my MATLAB window. I will just. So are you able to see my MATLAB window now? Can anyone just let me know?
Yes, sir.
So when you install MATLAB, if you have done installation, definitely. So when we install, we typically don't install everything because MATLAB now does have a considerable size. So one thing you can do is that if you need something and you don't find it, you just go and look it up as in the add-on part of things. Okay. So if you look at the very top part of this page, okay. So here there is this place called add-on. So add-on is the place where you can just go and get add-ons. Okay. So let's say I am actually working in a particular domain and I am finding something missing and I have the full license. Then I will go to Add-on Explorer and this is where I will search for things. Okay. So I was working with audio data. Chances are that I might not have installed the audio toolbox. Then you just need to go there and download that particular toolbox. So then you look for the toolbox and then you have to install it. Okay, so then you have access to the audio toolbox, right? So if you see here, although I have a MATLAB license, I can see many of the things it's not installed, right? So let me specifically look in terms of file by source MathWorks. So I will filter it by the MathWorks domain. So you can see I have not installed aerospace block set, communication toolbox, database toolbox, right? So these features I will not be having at my end when I'm creating my algorithm. Let's say I'm working with AlexNet. I don't even have AlexNet installed. Then it will throw up some sort of error. In that case, all you need to go is go to that particular toolbox and just install that, right? If you just install that, then it will sort of bring up an installer and it will install that. Once it is installed, you can very easily use it at your end. There shouldn't be any challenges with that. Okay. I hope this addresses the one of the questions which is there. I think there was one more question with respect to hardware, very similar. Let's say I have built my model and I want to deploy it to a particular hardware. Then again, I need to go to this particular part called add-ons, look at the get hardware support packages and identify which hardware I'm going to use it with. So this place actually has a list of all the different hardwares that you see here. Okay. So let's say I'm working with NVIDIA hardware. So let's say I'm working with Jetson. I want to deploy it to Jetson. Then I have to go there and look for the add-ons. So I can see that there is a hardware support package, MATLAB Coder support package for NVIDIA Jetson Drive, NVIDIA Drive platform. So I need to go there and install that particular package. So then that package will help me generate code for that specific hardware. And we have very extensive documentation for each of these things. So whenever you install something, if you want to know what that particular component does, what the installer does, or what are the features which are there, you can find that there is a link to documentation. Feel free to go to documentation and take a look at it. MathWorks documentation is very extensive and it has all the details. So it will have the installation setup for you. It will have examples for you. It will show you how you can actually create the entire deployment thing, right? So there will be supporting examples that will help you out to get started, right? So I have examples and all everything listed here. Installation and setup, and then examples that you can use at your end. So this is how you can explore different sort of examples at your end. So I hope this was useful. Let me take a look again at the question. So I like the new question. So Pooja is asking, Pooja ma'am is asking that for old version of MATLAB, can new toolboxes be installed? Okay. So this will depend upon when the toolbox came in. So if you remember the first slide that I was showing in, Uh, maybe I will just quickly take you to that slide so that we are able to relate. So I have this entire AI thing development here, right? Okay, I'll just go back a bit. Yeah. So in this case, let's say I am somebody who is working with the 2018 version of MATLAB. Then I won't be able to, let's say, call into occlusion as a command or use uh, code generation as a part, right? So you can see features that came in 2019 uh, can only be accessed in versions in 2019. If you are in 2018, you can use the deep network designer, definitely video labeler, audio labeler you can use. So all of them, if you see, it came up in 2018 only. Even before that, if you see, we did not have this sort of an app. So if you're using a 2017 version, then you would not have access to this particular app. Okay. So that's why we say that it's always good to actually migrate to a newer version, because there is always newer things which are coming up. Okay, so that's how the entire dependency is with respect to the newer features which have come up. Yeah. So that's a good question. I think that would help resolve some of the things that you see. Okay, so I see one question also, like, can we directly plot the graphs in MATLAB without models? So when it comes to plotting graphs, now what sort of so are you plotting graph from a model, means a mathematical model, or is it an AI model is what you are saying? So please could you specify that? Mathematical model, you can easily plot any graph. There is a function that allows you to do that. It's known as fplot. So you need to specify what you are looking at. Yeah. So I'll very quickly give you a glimpse of how you can find some certain things. So in case of MATLAB, let's say this is the command line, right? So this is the entire interface of MATLAB. Certain things we can do from the command line. If you want to look into documentation, let's say documentation of plotting, all I need to do is type doc and plot plot. It will open up the documentation with respect to plotting for me. And I can take a look at what are the options which are there when it comes to plotting. So I have this documentation with plotting. I can see what sort of plots are there. With some mathematical model, you can also do functional plot. So you can see other uses of plot. Right, so all the different uses of plot are sort of mentioned here. You can plot also different functions. Functional plot can also be do. It's known as fplot. So any mathematical function you can take and you can also plot within a certain interval. So that can also be done. Yeah, you can see some example and use cases also there. Any sort of complex mathematical function you can actually plot. So t into cos 3t sine t. So you can plot those sort of functions also. All right. Okay, so if that is what you're responding to, I think it's helpful. Okay. Okay, it's 10:15. I will sort of transition into one more example. Uh, Maybe we can take a small break now and then we can start from 10:30 if it is okay. Should we take a break now? So then we will go to
Yeah.
the next example. Yeah.
Is it comfortable for the participants? So, are you planning from 10:30 to
Yeah.
something 2
Yeah.
hours?
10:30 to 12 we are planning as the next step. Yeah.
Okay. Is that okay, fine for participants?
Yes, sir.
For everyone, right? Then we can have a short break on 15 minutes now. Then we can start from 10:30 with the same link. Okay. It will be put
Yeah.
on the same link. I will not switch off this same link, and you can join, take a break, and come back at 10:30. Yeah, is it fine, Dave?
Yeah, yeah, it's fine. Yeah, thank you,
Yeah.
sir.
Okay. 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 Thank you.
Yeah.
And the session attendance will be the second one will be considered, and it will be around after 11. I will provide after 11:30. I will provide. Okay. Thank you.
I hope all of you are back from the break. I will just wait for like one instance before I go ahead. Okay.
Yes, yes, please.
Okay, sir. Perfect. Thank you, sir. Okay. Okay. So I will address one thing before we go ahead. I think Priya ma'am, Dr. Priya ma'am has mentioned one thing, that is MATLAB expert a good data scientist? Okay. Uh, it's a very interesting question. So I will take this question from my perspective. Okay. So I am person from an interdisciplinary background, and I have mostly worked in the area of electrification, right? So my domain expertise is in the area of electrification. Additionally, I work in the AI domain. So when it comes to AI, uh, you have to look at what sort of application you are looking at. Okay. So applications could be many. If it comes to an engineering application, then I would directly say yes. So in an engineering application, AI plays a role as a part of a bigger system. So you should be able to use AI to integrate to a bigger system to solve some sort of engineering problem. In that case, effectively, MATLAB is very useful because you not just build the AI part of it, but you can design the entire system, you can integrate it with, you can test it, and then you can deploy it. So this is what many engineering industries which actually work on engineering problems, they actually use this sort of approach. So that is where the knowledge of MATLAB is going to come to be useful. Okay. So let me show you one example. So are you familiar with this company, SNCF? So this is a company based in France, which actually works on building trains. Okay. So what they were actually working for building a sort of a predictor, an AI based predictor to calculate any sort of a malfunction in the sensor data that they were accumulating. Okay. So when it comes to this sort of systems, so they were actually deploying this. If you see here, they were deploying it on a server and it was monitoring the health of the train in real time. Okay. So it was anticipating failure and identifying when critical maintenance is needed. So in these instances, it's just not an AI model which you are building. It should actually integrate with the server system, and it is actually part of an overall engineering system, right? So this is an instance where actually MATLAB is very useful. So in this case, they were actually able to use MATLAB to specifically able to identify abnormal behavior from the sensors and identify when there is going to be downtime. So if you see here, it's like part of a bigger system, right? A bigger engineering system. And then there are domain experts who actually build this sort of AI systems. So it is not just an AI person going and working in this sort of a domain. It is a domain expert with
Sir,
expertise in the,
are you
yeah.
sharing the presentation slide?
Oh, yes. Sorry, I think that was a good feedback. I think you are not able to see anything.
Yeah, yeah, yeah. You can just reshare something. Yeah.
Okay, let me just quickly reshare. Okay. Okay.
Thank you, Pooja, for
Yeah,
informing
yeah,
that.
thank you. I think that was helpful. Yeah. Yeah, thanks for that feedback. I think very helpful. I think you are able to see my screen now, right? Yeah. Is the screen up now?
Yes, yes, sir. Please
Okay,
go ahead.
okay. Yeah, sorry. Yeah, I think that's a very helpful feedback. So this is what I was talking about. So companies like SNCF, so they are building these trains. So what they want to do is that they want to have a sort of a system that is able to integrate any sort of abnormality in a system. So here, just for an example, it is given as an indicator for the battery system. So what they are doing, you can see they are looking at the current discharge quantity. There are certain indicators based on the performance indicator. It should be able to predict when, let's say, the battery charge is very low. So this sort of system, if you see, it is running, although it is deployed on a server, it is actually related to an engineering system. It is monitoring the health of train in real time. So in this sort of system, it is domain experts who are building these AI systems. Okay. So you need to know about this domain. You need to know how you can model a particular train, how you can model the dependence of certain data on the performance on the train. So in these cases, MATLAB definitely helps because you just not build the AI system. You can build the entire sort of the engineering system around the and then integrate AI to that. Okay, so they were able to successfully do this sort of a thing. Okay. Just to give you the perspective, this is one more example. So this is coming from a company known as Voyage. So this is like a third generation automate or the third generation autonomous vehicle based on. So this has been tested and tried. So this is in a retired community. So people who are not very comfortable with driving, they take services of this sort of car. You just need to give them the location. The car will automatically take you from one location to the other. Okay. So you can definitely understand that this is quite not a simple system. There are multiple sensors which are there, and then there are algorithm which is tracking that the car is going in the correct direction. It is able to identify the different obstacle based on sensor data. So AI also plays a very important role there, but then you have to design an entire sort of an you have to design an entire sort of a application around that, right? It's not just a simple case of just one algorithm working. So verily in this case, they were actually able to use MATLAB and specifically Simulink as a platform to build the entire model of the system, test it out, and then sort of deploy and test it with respect to a prototype, right? So the entire thing, they use Simulink as a rapid design platform, and AI was like integrated as a part of the system, right? So it actually helps people with a background with the domain expertise to actually integrate AI as a part of the system. Very similar. This again comes from Hyundai Steel. So what Hyundai Steel was doing is that they were having a lot of data at their end. Based on the data, they wanted to inspect whatever data they had and then automatically label that. So you can see that they were having this sort of picture and then automatically they wanted to do a bit of labeling. So uh, to do this labeling also, you need certain domain expertise to understand what the data actually means. Okay, so they created a custom labeling algorithm which allowed them to automatically label the data sets that they were having. And they had very good sort of prediction accuracy when they use the data in the deep learning approaches that they do. So they very closely work with MathWorks to leverage the full benefit of MATLAB to come up with this particular application. Okay. So they were able to reduce the human supervision and development time in this particular application. So in all of these instances that I talked, the three user stories, it is people with a domain knowledge who are trying to build AI systems. So they already know that, okay, uh, this is what they want as an outcome, and it is an engineering problem that they were tackling. So they could integrate AI into that using the approach that we sort of saw. Okay. So this is where companies are actually using AI and integrating at their end. Okay. I hope that sort of addresses like uh, what sort of applications people are looking at when they're using MATLAB. So it is this sort of applications which they are actually looking at while using MATLAB. Okay. Okay. So from Hyundai, they say that they actually had knowledge of the domain, but they had actually very limited knowledge on image processing and deep learning. But still, they could successfully adopt this deep learning for their project. And they could prototype this with very limited time, limited sort of a time and very limited sort of a knowledge to start with. So this is something that you can also try it at your end. If you have an application, you can actually build it in very less time, because MATLAB and Simulink, they have tools uh, that we just saw, like Deep Network Designer, which allow you to uh, uh, work with the algorithm in a very easy way. Okay. So there are tools and workflows that actually allow you to save a lot of time. Right. Okay. Back to the problem. So this is the problem that we will sort of solve. So again, we will use the data-centric approach. So in this case, the difference compared to the previous one is that in this case, what we want to do is that we want to identify, we want to take sound from a air compressor. So you have heard, I think you are familiar with what air compressor does. All it does is that there is a motor there, and then it compresses the air and allows you to have air at a certain pressure for a particular application. So just by the sounds, are we able to classify whether the air compression is working properly or not, is something that we are going to look in this particular demo. Okay. So this is the second example that we will look at. So let's go into that. But before going into that, let's address one important question. Okay. So in this case, if you see, so we are starting with data, some signal data. We are transforming the data, doing feature extraction. Then we are passing it to a neural network, training it, and then we are doing it for prediction. So why is this additional step coming in the picture? I told that data-centric AI, this is a very critical step. But what would happen if we take away this particular step? Let's say I don't do feature extraction. What do I expect to see in terms of, let's say, the workflow? And what do I see in terms of the results that I will be seeing at my end? Okay. Yeah. So this is the important thing, step that we are recommending that you should take. So what happens if you do not take this? So let's say if you have just plain time samples. Okay. So what we are doing is that, so let's say, let's first see what we are doing as of now. Okay. So my question is, why don't we directly use this time sample, and why are we converting it to a, why are we doing this sort of a spectrogram sort of an approach by extracting certain features from the data? Okay. So first thing, let's look at what we are doing, and then we will look at what happens if we don't do this. So time frequency transformation, this is the thing that we are doing. So this is the important step that we are talking about. So this is the feature extraction step. So in this case, we take this time sample. Okay. First, we buffer it. So you can see that we take small frames. Okay. And then in each such frame, we actually apply FFT. Okay. So after we do FFT in each case, what happens is that we will have certain output, and that output we concatenate. Okay. So if we concatenate, then we would have, with this sort of a time sample input, we should have this sort of a output, frequency versus time output is something that we are going to take. So this is the step that we are doing with the raw sample, raw signal samples that we have at our hand. Once again, just to reiterate, we take time sample. We have these small windows. Sorry. Yeah. So we are taking small windows, and then we are applying FFT. So thereby we are getting this sort of an image. Okay. And we can have multiple images, right? So based on a certain sample, we can have multiple of these sort of images. Okay. So this is what it would look like, something, let's say if you're doing it in real time, this is something that how it should appear to look like. Okay. So if you miss this important step, then what are the things that you can encounter is something we will understand before going to the next example. Right. So let's say you are working with raw signal. Okay. So if you're working with raw signal, you might have something like this. So I'm taking some samples of the signals here, some time-based samples. I'm getting something like this. I'm getting something like this. I'm getting something like this. Do you think we can use this as an input to a certain model and train that model to get some good output? Do you think we can do that? Alternatively, you can also think about, I have these three sort of data sets of signals. Are you able to look visually and identify the features in this data set? Any feature? So this is just a question for all of you. Are you able to look at this data set and identify any feature? See. Yeah, so I think that's a very good sort of feedback. Exactly. So there could be some noise in this. That's good. But let's say there is a way I am able to reduce this noise or in some way extract part of the noise. Do you still see some features? Are you still able to see some features here if I remove the noise? Definitely there is noise. But if I remove the noise, do you think we will get some features? Yeah, so that's very correct. So uh, Vikashini says yes. Yeah, some processing might be needed. So that's also correct. So without doing any processing, with this raw signal, definitely no. But I can even say that even if you remove, even if you sort of remove the noise that you see here, chances are that identifying any meaningful feature, even if even if I'm a domain expert, is not very straightforward. Okay, so that's correct. So what else? If I do the transformation, so if I take the time frequency transform, now I have three spectrograms. So each spectrogram corresponds to the image above. Now, are we able to identify any feature here? Yeah. Okay. So maybe I should give you the answer, right? So in this case, if you look here, after doing the transformation, I can clearly see. So this is the after doing the FFT. So the spectrogram, if you see here, just from the magnitude only, I can see that I'm having very specific signatures for these three signals, right? In one of the cases, it seems like the magnitude sort of changes with respect to time and frequency, right? With respect to frequency, I can see there. In the other case, I clearly see this sort of a spectral signature, this sort of a wave-like thing. In the third instance, I can see something. The yellow. If you look at the yellow sort of uh, this particular line, it starts from a particular lower frequency and then it doesn't rise a lot. It sort of goes and then sort of saturates. So I can clearly look at the features, even visually I can see and I can understand that, okay, this is the feature corresponding to this signal. This is the feature that I'm getting corresponding to this signal. So it visually also, if I can identify, I can understand that if I feed it to a CNN, it will be very easily able to identify this particular characteristics. Okay. Now, I'll not go into the details of this particular example, but if you want, we have one more example where you can understand more about feature extraction, but more about what other things that you can do. Okay. So this is something that we did for this sort of a signal. What if I give you a data set which looks like this? So this is an ECG signal. Okay. So this is again, we have this example here. If you want, you can take a look. So in this case, this is something that is used by cardiologists. Okay, so these are the ECG recording. In this case, we clearly know that this is the sort of feature that which I'm looking for. Okay, so if I have any raw data also, chances are that even without going to the FFT, I can actually label this sort of signal at my end also, right? So there is a signal labeler app. You can automatically label this sort of signal and then use it, let's say, for training an algorithm. But do I go with that or do I again use FFT? So for this case, definitely we use FFT. What about you had signal like this, like an ECG signal, where just looking at the signal, I can sort of look at the features. So now the question is that do we use FFT here or can we proceed training our algorithm with this signal? Yeah. So Pooja ma'am, thank you for the response. I think it's really good to see your interaction. So Pooja ma'am says that we don't need FFT here. Okay. Yeah. So I would sort of agree that probably you don't need to go for FFT here because you have such good signatures, right? You can very easily identify which is the P wave. So P wave is this one, which is the QRS, which is the T wave. You can very easily identify the features, right? So as a domain expert, looking at the signals, sort of you can identify that whether I need to use feature extraction or not. And if not feature extraction, chances are that I can actually do with the automatic labeling part and then use it to train my own model. Okay. But so here in this case, if you look, you can just take a simple recurrent neural network and sort of come up with a model. But the thing is that if you are not, again, you are a domain expert, let's say, you understand the feature, you label the data, you feed it to your network. So people in this case actually work with very simple sort of networks also. So if you are not an expert, maybe you design a very simple recurrent neural network. Then what happens if you train your model with a simple recurrent neural network? You might end up with lower accuracies. So this is not a very good sort of an accuracy given the medical applications we are looking at, right? So you can see we have not very good accuracies. In that case, what can we do? Alternatively, we can have more complicated models, right? We can have more complicated models, or we can again do the transform and then use a simple recurrent neural network model to have better accuracies. Just compare the accuracies. So what do we learn? So intuitively, what we understand is that first thing is the data. Definitely, if the data doesn't have very good features, like what we saw in the previous, then definitely we use time frequency transform. But even if you are able to identify the features very properly, if you are using a very simple sort of a neural network, your accuracy might still suffer. So in that case, one recourse is to use more complex models to have better accuracies, or you can do again a bit of feature extraction, go for time frequency transform, and your accuracy is going to improve. This is what we see here, right? So this is what we said. Alternatively, you can go for a very complicated neural network model, that is fine, and have better accuracies. But then for this one, you will also need a lot of data, right? You'll also need a lot of data. So that will also raise one more challenge for you. Okay. So feature extraction not only reduces uh, uh, I would say it not only reduces the model that you need, you can work with simple model, but you can also work with less complex data set. Okay, data complexity problem also is sort of addressed by this particular approach. Any question on that before we go ahead? Yeah. So ma'am has very correctly stated that you actually need to uh, sort of develop this sort of an intuitive understanding so this will come with practice. So once you have a lot of practice, you will sort of get an idea that what sort of approach you should use. The other thing is also that one should, I would say, consider is that you have to read a lot of literature. So definitely nothing around that. The more literature you study, the more you can understand that what are people in your field using. Definitely that is there. The third thing would be to practice, to try out things. So when you try out, definitely you will also sort of have better idea. You can try to look at data from different sort of domains. and then try to see what sort of approach can work when you go for feature extraction, when you go for a more complicated model. So that will also come from experience as well as for reading what other people are doing in your particular area. Okay. Okay, so now this is clear. So probably now we can look at the next example. So the next example, what we are going to work is working with air compressor sounds. Okay. So here we are going to work with LSTMs, long short-term memory network. So very much related to what we just understood. And then we will also do a bit of feature extraction here. And then based on the data set that we have, we are trying to go to look for anomalies. So air compressor, there could be certain anomalies when it is not properly running. And that we need to identify based on the signal data that we have at our end. Okay, so this is the end goal that we are looking for this particular example. So this is again an example which is taken from our website, but this is something that I will do from my end. And if you want to follow along, you can actually take a look at the example page. So this is the example. Feel free to take a look at this example and try it at your side. Okay. So anyone had experience with air compressor before? So have you seen an air compressor or have you used an air compressor at your end? Do you know what an air compressor actually is? So I'm not sure of what background you are from. So that is the reason I'm asking this question. Uh, so are you aware of what is an air compressor? Okay, that's very helpful. Thank you for the response. Yeah. Oh, you are from biotech background. So I think we have participants from different backgrounds here now, right? So I think somebody from mechanical background might be more familiar with air compressors, mechanical or electrical probably. So I will give you from my background. So I used to work with fuel cells. So in case of a fuel cell, what it does is that it produces energy from hydrogen. So you feed in hydrogen from the inlet at the outlet. So you have to feed hydrogen from one side. One side you feed air with, and there is an electrochemical reaction that take place at the catalyst level, and you get electricity out of it. Okay. So when you have a fuel cell, uh, you have to feed hydrogen from one side, but you have to feed air from the other side. The air has to be pressurized. Okay. So when the air is pressurized, then only it works at the optimal efficient level. So how is that? So how is the uh, air compressor coming to the picture? So air compressor will actually provide uh, that compressed air, that pressurized air to the fuel cell. Okay. So this is how I experienced. So we had something like an air compressor. We used to connect that air compressor to the electric socket. So here, if you see, there is a motor assembly, and here there is a chamber where air is pressurized, and that air is connected to the system that I had at my end. Okay. So when you run an air compressor, it has a certain sound that comes out. So here you can see I have the sound of an air compressor. Okay, because there is a motor running inside and there is a periodic motion that happens inside. We will have audio signatures like this. Okay. So when you have a healthy air compressor, the signal looks something like this. You can see the signal here, the above one. Okay. And when there is some sort of anomaly, so this is given with respect to one certain anomaly, the signal, nature of the signal is changing, right? You can visually also identify that nature of the signal is changing in this particular instance. So what I want to do is that, let's say I have some data set at my hand. I should be able to identify when the air compressor sound is healthy, and I should be able to identify when it is faulty, and if faulty, what sort of fault is there in the particular in the particular machine. So based on the audio signal, I want to classify what sort of fault is there in the data. Okay. If you want to try this example out, you use this link. I will share it also with sir. Okay. So you can take a look at this. So here I have 1,800 WAV files. So audio files. There are 7 different type of fault, and I should be able to identify what sort of fault is occurring. Okay. Okay. So let me first open up this particular example. If you want to open up this example, just click on this link in the presentation. Yeah. So in MATLAB, it will go and open up this page for you. Okay. So this is the entire example which is there. So this is in the form of a live script. Okay. So the way you can open up it in MATLAB is to copy this command, copy, and then you have to paste it in the MATLAB environment. I will just close a few things. Close a few things. Yeah. If I paste it here and press enter, this example should open up for me. Yeah, it's busy. It will open up that example for me. Okay, this is one way. This is one way you can open up a particular example. Okay. So I can see the example is opening up at my side. So if you want to try it out later, feel free. Go to this particular link that I provided and just sort of take a look at that. Okay. Yeah. The other thing that I just want to stress is that MATLAB is not just for the installed version. If you have a MathWorks license, which is connected typically, if you have a campus-wide license, it's connected to your email ID. You can open an instance of MATLAB in the cloud also. So this example, if you open up in MATLAB online, it will directly open up in the cloud version of MATLAB, which runs in the cloud. And you should be able to see the example opening up right here also. Okay. So I think bandwidth being consumed due to the Teams broadcast. So my internet is also not very fast. So it's opening up. Sorry. Okay, so it should open up here. But again, it's not a, I would say it's not a easy option for me to go because I can see it's constraining my bandwidth. But you can run this example also in the online version of MATLAB. So this is the online version of MATLAB. Everything is very similar to how MATLAB looks for the installed one. Okay. But this is going to run in the cloud and your files get stored in the MATLAB drive. Okay. So later on, if you want to try, you can use any of these approaches. I will use for the installed one to go ahead with. Okay. So what will be my first step? I have opened up my data, opened up my script here. What will be the first step that I will do? So if you look here, the first step that has been recommended is to load the data. Are you able to see the example? Just a quick check that you are able to see the example at your side.
Yes, 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 sir.
Okay, okay, that's great. That's great. Thank you. Okay, thank you. So just to save time, I have actually downloaded the data set. Or did I? Okay, I will run this and I will try to see what comes up. So first step is that the data set, if you see here, it's being downloaded from this particular reference. Okay. So it's coming from this particular publication by Verma et al. So the way you can go is that this particular example, if uh, it can be downloaded by using this particular command. So it's coming from the MathWorks examples page. Okay. So this is the author and we have been able to get access to the data set. So it will download it as a zip file. Okay. With the zip file, if you look here, we can see all the details. What is the data set? Where am I downloading? I'm downloading it in the data folder. And then I'm going to unzip it. Okay. I will unzip it to see what is the content here. Let me run it and try to see what we get. I will put a section break here. So in MATLAB, what you can do, you can introduce this section break. So this is like a live script. Okay. In case of a live script, this is where I write my command. This is the part where I explain sort of, I can write some text to explain what this command is doing, or I can write text to make this example easy for users to understand. So what I do, I will just execute this first part. I can click this blue bar, it gets executed. So data folder, it was able to do that, and then it is unzipping everything. So let's look at data folder and try to see what's there. So I can see a data folder that has created here. Okay, let me access that and try to see what's there in my data set. So the name is data folder. What I will do in command, I will write data data folder, right? FOLDER. So I can see that when I type data folder, which is where the files are, it is pointing to a particular location. Okay, I might copy this location at the very top. So this is the path. This is the place where you can see the current folder I'm working in. So I've created a folder called Data Centric AI, where I'm working with the particular file. So this is the file that I'm working with. It's kept here. So I will go to a different folder to check the data set that has been downloaded and unzipped. So this is the place where I can see the data set. I can see something like air compress data set. Again, I will zoom it a bit and we will look inside what we have in this data set. Okay. Yeah. So if you see here, I have all these folders, right? Bearing, flywheel, healthy, LIV, LOV, NRV, piston, rider belt. So healthy has all the files. If you see here, all these files which are there. So we have extension files. So this is the files with audio for a particular uh, so in this case, if you look here, uh, this is for the healthy sort of thing, right? So whenever I'm taking audio sample for a healthy instance, so it will have files here, and any sort of the others, if you look here, 1, 2, 3, 4, 5, 6, 7. So these 7 are for whenever it is not in a proper working condition, it's unhealthy, right? So if the air compressor has a problem with the rider belt, it will make sound like what I have here. If it has any problem with the bearings, then the audio samples are here. So like this, I have divided the unhealthy ones into the other 7 categories. So this gives an idea of what is the data set that I have at my hand. All right. We will go back to the folder which we were working with. So the first step is done. What do we do now? Very similar to what we did before, we will create an audio data store. So this step also we are familiar with. ADS will create my audio data store. So I have an audio data store here, and it will access that particular data folder that we created before, including all the subfolder, and it will label everything. Even the subfolder it will take and add to the entire audio store data path. Okay. So this is one thing, ADS equal to audio data store. So I have actually run this before. I will just go back once. So I have done this audio data store part also, and I have divided this data set into 3 parts: training, validation, and testing. How did I split it? So this command split each level. So this is a command that allows me to split this data store into 3 parts. Training is 70%, validation around 20%, and testing is around 1%. Okay. So let's take a look at the audio data store just to get an idea about what I see here. So my audio data store, as of now, it's in this variable called ADS. So again, I can just type it here just to see the contents of ADS, and I can see it is accessing my data set, and I can see the folders also. Shows me a glimpse of some of the files and how many files are there. It also tells me what are the uh, categorical data, and it also tells me that what are the supported audio formats also, and the default audio format here is .wav. So till this part, I think it's clear. And then uh, there is one additional thing that we are doing here. I will take a section break here just to showcase. So in this case, we are not directly using the data set to train our algorithm. Very similar to what we did before, we are doing a bit of transformation. So we are doing feature engineering. How are we doing this feature engineering? So to do this feature engineering, we are doing this transformation here, transform. Okay. How do I do this transform? I will take the training data. Okay. At the rate audio process means I'm calling a function here called audio process. And then all the information is included. So include info equal to true. So here audio process will call something known as a YAMNet preprocess, and this will generate the MEL spectrogram for me. Okay. So this MEL spectrogram which it will create will be useful for training using the network known as YAMNet. So each audio signal will produce multiple spectrogram, and we will duplicate the class level for each spectrogram. So where is this thing called audio preprocess? So I believe, yeah. So this is the supporting function. It's written in the very end. So in case of MATLAB, when you write this sort of functions, you typically write it at the end of your script. So this is the script. At the very end, we have written this function, audio preprocess function. It uses YAMNet preprocess to generate the MEL spectrogram from audio input data. So I have audio input data. I use the YAMNet preprocess to generate the MEL spectrogram, which can be then sent to the YAMNet network. Okay, so this is the function. It takes the data and does this uh, thing in a loop. It will run over all the data and create the spectrogram. So this is the YAMNet preprocess spectrogram. So this comes from the I think the audio toolbox that we saw before. So if you have the audio toolbox installed, you can do this particular. You can call this particular. I can just check. So whenever you are unsure what something does, you can just go and just check. Sorry, Control V. Okay. Sorry again. Yeah. So you can see that this is actually yeah. So this is a release in 2021A, and it generates MEL spectrogram from audio in that can be fed to YAMNet network, and some example is also given how you can do that. Okay. Yeah. So whenever you have something that you sort of want to understand, then you can just go and check for that, and you should be getting the entire details of what that particular command does. Okay, any questions so far? Yeah. I think that's a very good comment from Pooja ma'am, that in petrol pumps also you see these sort of systems, right? So it's nitrogen can probably be used, and then it's very good that we are able to relate it with our own experience. So that's great to know. Any other questions? Do let me know. Okay, so you get the gist that what we are trying to do. We are trying to now do the feature extraction part. So YAMNet preprocess, this is the one, I think it comes from the audio toolbox, and this will allow us to do this particular part. Okay. So let's go back to the example that we have. So we were somewhere here. So if I just run this, this is where it will start creating the spectrogram. So I had run it a bit before, so it was able to very quickly go through and create the spectrogram for me. Okay. Now the thing is that now we have the training, validation, and test data as spectrograms. So this is where it is. I think TDS. Yeah. So what next? So now I will take this data and train my algorithm. So for this, I can go to apps here. at the very top. So these apps are there that allow us to do our tasks faster. So these are the common apps that I use. I can find it here. But apps are also listed according to domains. Okay. So this is the part where you can see different apps, and apps are listed here based on domains. You can also create apps at your end. So these are some of the apps that I have created. And you can create and share apps with other users also. That is also possible. We have something known as an app designer that allows you to create these sort of apps. So we are going to look at an app that is created by somebody from the MathWorks staff. Okay, so this is the part where we look for apps. So these are all the apps that could be useful for AI. Okay, so since we are exploring apps, let me just give you an overview of some of the useful apps that you can take and use at your end. So Deep Network Designer is the app that allows you to work with different sort of networks. This is the one that we will use. Apart from Deep Network Designer, we have some other useful apps also. If you are working on machine learning algorithm, we have something known as Classification Learner. Allows you to classify, allows you to train different machine learning models that can be used for classification. There is something known as Experiment Manager. This is an app that allows you to work with the different hyperparameters in a deep learning model and uh, sort of run experiments and find out which is the best hyperparameter to use. There are also some other apps related to neural networks. There is a regression app also. So all these apps are there which allow you to actually work very effectively with any sort of data. So I will go for the Deep Network Designer app. Okay. So it will open up the Deep Network Designer interface for me. Okay. So now what you can do here is there are two ways we talked about, right? One is the starting from scratch where you build the entire network from scratch. So here you can go and do new. So in this case, you have to build everything from new. So let's say I have a network which has certain inputs. So I will just drag and drop here. Image input. Maybe I will need a convolution 2D layer. And whenever I'm dragging something, there will be some attributes here corresponding to each of the layers that I'm sort of bringing here. So depending upon what sort of network I'm sort of building, I will drag layers and connect them together. So maybe I will have some sort of ReLU layer, right? Some sort of pooling layer. So very similar to how people sort of build networks. You can actually sort of build any simple network here, simple or complicated network, any sort of network you can build. And finally, there would be some sort of a classification network. So this is like a very simple sort of a network I'm just dragging just to give you an idea how you built it here. Okay. And then for each layer, you can mention the attribute in this particular part. And once you have mentioned the attribute, it should work fine. You just need to connect them properly. So it's a drag and drop environment. It's a very easy way of actually sort of working with network. It's very convenient. You can actually build any network from scratch. Once you build the network, what I can do, I can auto arrange. Everything gets arranged properly. Okay, and then I can sort of analyze. So I will fit to view and then analyze. If I have any mistakes in my particular network, it will throw up an error here. Okay. As of now, it says 0 errors, but let's say I miss something. Let's say I miss one of these arrows. So it will analyze and throw the particular error for me. It's very easy to just look at and understand what sort of error is there. Right? It is throwing three errors, right? And it also tells me where the error is. So it is identifying the error is towards the beginning, somewhere in the image input layer or the convolution layer, because they are not connected. So once I connect it, once everything is proper, you can actually come and have a look at it, and it will say that it doesn't have any error, right? Apart from that, it also gives you, if you want to know what are the weights and biases you have, the total number of learnables, you can also summarize that. You can see it here, summarized here, how many learnables are there for each layer, what is the weight, what is the bias, that sort of a thing. And then once you are happy with that, then you can go to the training part. So then you can take data, import the data, train this network, and then look at the performance. So training part can also be done from the deep network designer. Okay. So in this example, currently I am going to work with YAMNet. So in that case, I don't want to build the entire sort of the network from scratch. So instead, what I can do, I can go to new. Okay. And then I can search for that particular network here. Okay, so I can search for networks here. So I'm working with audio networks. So here you can see lots of image networks are mentioned. I'm working with audio networks. So I can go here and search for YAMNet. Okay. So if I open it up, I will do replace. So it will import that pre-trained network YAMNet and display it for me in this particular instance. Okay. Yeah. So you can see I have a network with around 86 layers, right? So it has 86 layers. Number of connections are around 85. And if I want to go closely and visualize how it is built, I can just zoom in. Yeah. So I can zoom in, and then I can look at each layer and the details of each layer also here. Input layer, convolution layer, patch normalization layer, activation layer. There is this layer also, depth-wise, some sort of group convolution 2D layer, patch normalization, activation, and I think there's a repeat, convolution, batch normalization, activation, depth-wise. So then I have a repeat of that also. So if needed, you can take some layers and you can also copy paste and then create bigger networks, right? So that is also possible. So my next step here would be to take this particular network and then train it with the data sets that I have at my end. So what should I do now? If you have followed along, give me some direction. What should I do now? In the chat, I will just quickly look for answers. If you can give me some hint of what should I do now? Yeah, so I think you're also you are also correct. A very similar sort of thing is also used for deep freezer probably, because any place where there's a motor and you are pumping some fluid at a particular pressure, you would need this sort of air compression. So Pooja ma'am says we will provide training data to the model. Okay, so intuitively it looks like that I have the network. Let's pass the data and start training it. But see, we have a pre-trained network, right? We are not building a network from scratch. I have imported a pre-trained network. Is there something different that I need to do? Can I directly start training this particular network with the data that I have? Or do I need to make some changes here? Just a quick sort of a thing to think about. Do I need to make some change here or what? This is a pre-trained network. I will give you a hint. Okay. If I go down, 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 down to the very end, I will see something interesting. Classification. Can you see the output size here? What does it tell? So just see the classes also. So can I use this network directly? It might not be, right? Let's see if you are able to figure it out. Yeah, exactly. So if you see here, this particular network has an output where the number of classes are around 521. Okay. Same thing. If you look here, I have to make change so that if you look at my data set, I have only 8 categories. One is for a good sound and 8 categories for sound with some sort of faults, right? So this particular last layer, it has 521 as an output, which is not useful for me, right? So I have to make changes here. So I will delete this. Softmax, let it be. I don't have to do. This one also I will make a change. Okay. So what are the things I'm going to need? I will need a fully connected layer. Also, I'm going to need a classification layer. So in case of fully connected layer, I have to connect it now with the previous set of previous network which I have. Connect it to softmax, connect it to output layer. Okay. So now I have connected everything. What else do I need to change here? In case of this one, class output, okay, it has kept things as auto. Yeah, output size in my case, we all know. So we have trained it. We have 8 data, 8 sort of categories. So I put it as 8. Also, I'm going to change the learning factor, learning rate, because if I keep the default one, it is going to be very slow. Based on experience is what I can say. Okay. So I've done everything now, fully connected. I put the output size. Softmax converts the output of fully connected into probabilities, and based on probabilities, class output tells me which category that particular sound belongs to. Okay. Again, auto arrange. I can sort of analyze. Here I can see how many total learnables are here. Almost 3.2 million. Okay, we can see there are 86 layers. And I can also, if I want, I can look in the details of all of this also here. Okay. So now I think we are good. Now we can go to the data step. So I can go to data. Okay. I can import data here if I want. So import custom data is possible. Import image classification data is possible, but I will go with import custom data from a data store because I have already created a data store. I will go for this particular option here. Okay. There are two things that I need to identify here. One was the default data set. So that will not work for me, right? So that I will not go with that, but I will, as of now, keep this. If you want from your end, you can try to see what happens if you use this data store, not the transformed one. We will use the transformed one. The transformed one is the one given here. Okay. So this is the training one for train, and this is the validation one. Okay. And I will import it. Here I sort of get a black and white picture, but I get a representation of how these audio signatures look in terms of spectrogram. So for bearing, it's been showing first 5 observation. It is just showing how the data looks like. Okay, to give us an idea of how the data looks like. Then we go to the training option. So data part is now taken care. So go to training. And then you have to select training options. So here you can identify what sort of learning rate you want to use, what is going to be the batch, mini batch size, what will be the maximum epoch, validation frequency, and all those details. Apart from that, you can choose the solver rate. So the different, the things that we were providing it before by code, that same thing we are going to provide it here by using this training options part. Okay. So let me just go and check my example once more and just see what sort of training options were provided in the example. So here we have prepared so steps are given. If you want to follow this example, the steps are given. Do try it out later. So we have replaced the last layer. We have made these changes: output size, the weight, learn factor. These two changes we made so that things uh, sort of give result in a faster way. Yeah, and yeah. So at training time, classification layer, we do not need to do anything. Automatically, based on what I've given in the fully connected layer, automatically it will set the output classes of the layer from the data. Okay. This is also done. Here we have imported the data that we have. Here we will make some changes. Learning rate, if you can see here, it's 0.0001. Mini batch size is 128. Maximum epoch, we are just putting at 2 as of now. Okay. So what we want to do is now, we want to sort of increase the, so you can see here, select the training tab, select training options. Initially set the training rate to small value to slow down the learning rate. In combination with the intrinsic learning rate factor for the fully connected layer, learning is now faster only in the new layer and slower in the other layer. Okay. So this change we will make and then we can start training. So solver we have to select. Solver is Adam. Initial learning rate is 0.001 and maximum epoch is 2. So let's do that. So, okay, I will just put this down so that it's easier to see. Solver is Adam. Initial learning rate is 0.001 or 0.0001. Okay. Okay. And maximum epoch is 2. Okay. Good. So we have done this part. Okay. So now we can start training. So now one thing more, if you have GPUs at your end, you can take the help of GPU. I don't currently have in this current laptop, but I will start the training. And this progress, training progress, we can see here in this part of the screen. Validation data is invalid. Okay, so let's go and check what we have as the validation data. Okay, I did not make a change probably. Train. Okay. Import. Training. Let's see. So that's why it was that time telling that you need a bit of patience also, right? So yeah, so I think it has started the training. I can see that it has sort of made the training window here. I can see that it is using a single CPU and it has started with the learning rate that I have specified. It might struggle a bit given that I have so many things things open, but let it get started and then we will continue from there. Okay. 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 Yeah. So it has started the training. Let it continue for a bit and then probably we will take a look at it. Okay. So again, it might take a small amount of time, I believe. So I think we are at 11:35. We can probably give it around 10 minutes. So if you want to take a break, I think we can have a small 10-minute break and allow it to train meanwhile, if it is fine with you. And there is a hand raised. If you have any questions, feel free to let me know. Okay.
Jason, do you have any question?
Yeah. Let me know if you have any question.
Yeah, if you have any other questions, just unmute and ask.
Yeah, yeah, that should be great. Yeah, thank you, Dr. Rahul. That helps. So I will allow it to train. Maybe we can have a small 10-minute break so
Yeah,
that
please.
we
Yeah.
get to see the result. So we will continue. I will let it train. It will be open, but I will just keep myself muted and my video off. We will continue from 11:45. Okay. Okay.
Okay, thank you.
Yeah, thank you. Yeah, I hope everyone is back now. Just I'll give a moment. And timing wise, I think we are perfect because I just saw that right now at 11:45, it sort of finished the training. And you can see that it has converged, sort of. So what are the things we can observe from this? So one thing I can clearly observe is that the validation accuracy is quite high, right? It has jumped up very fast. And then the validation, because we had the epoch, if you see, we had just two epoch, right? So that was one of the thing. So the validation accuracy is quite high. And then as of now, uh, the learning rate was also quite low, the value that we had used. So if we think that the results are okay for us to go ahead with, so then what we can do, we can take this particular model and we can sort of export the trained network and result if you want. We can generate code also. Let's say if you have trained it once, if you don't want to train it every time, you can generate a code and use it later for training. Okay. What I also mentioned was that AI is typically part of a larger system. So if we are building, let's say, an engineering system around this AI model, then we can export it to Simulink and use it as one of the blocks to create the bigger engineering system. One more thing, what we can also do is that the hyperparameters as of now in my model are yet not tuned. So although I have a very high validation accuracy, it might not be the case for other scenarios. Okay, there could be scenarios where the validation accuracy might be less. In those cases, what we can also do is that we can create some experiments. So creating experiments meant we are going to change the hyperparameters and try to see whether you can improve the validation accuracy. So depending upon what we are planning next, we can select any of these options. Okay. So let's say I just want to export this trained model to workspace and use the test data to see what sort of accuracy it sort of provides. Then I can export this. So it has exported the trained network. So the name is exported trained network underscore one. Okay. And whatever training data it had, that it has also exported to the workspace. So I can do OK. I can go to my workspace. So in my workspace here, I can go and I can identify my trained network. So this is a trained network that I have just trained network underscore one. Okay. So this network now I can use further to test, to look at what sort of accuracy I'm getting with respect to the uh, test data that I have. So this was the previous one. Let me clear this output as of now. Uh, okay, it says clear all. Let me just run this once again. We will be able to see what sort of accuracy it is getting as of now. Okay, so it's giving me an accuracy of 0.9784, which is around very close to 98%. So if I'm happy, I can take this network and I can go and create any further application. What I can also do is that I can take this network. Let's say I want to save it, let's say, and then use it for something else. I can also save it. It will get saved as a mat file. I can give some sort of name. Let's say we were working with air compressor, so I will name it air compressor. And I will save the mat file. And we will be able to see, okay, it will, yeah, we have saved it here. So I can see that mat file here. That can also be used for some other cases. Okay. So this is how the entire workflow is. If needed, let's say I want to work with the hyperparameters, then I can create one experiment by going to experiment manager. So it will create a template for me and open up something known as an experiment manager. Okay. Yeah. So in many instances, what you might want to do is that you might want to change hyperparameters and try to see how the entire the validation or testing accuracy changes. In that case, this is one more app. So this is again part of, if you look here, it comes from home, apps, the same tab, machine learning and deep learning. This is the experiment manager app where you can create different experiments with learning parameters. So you can see my initial learning rate mentioned here. I can add and create other sort of learning rates also. Okay. So this is what we can do. We can create different sort of learning rate, and we can run these experiments and then try to see if we can sort of improve the accuracy with respect to hyperparameter. So whatever parameter I want to work with, I can actually put it here. So maybe I want to check what happens if I work with different sort of initial learning rates. And maybe I can start with some different value. Maybe, okay, so if, above only we have created with 3. Okay, so we can do with others also. I think we can delete this one. It has already created 2. So I have taken 0.001. It has taken one as 0.001 and one as 10 to the power minus 5. Okay. So once I have this sort of a thing defined, we can actually just run it and it will take the same model. So, okay. I think one has to create it one by one, probably. Yeah. And then you can sort of run this sort of experiments in the background to find out what sort of hyperparameters to use in your own model. Okay. So I'm not going into the details of this right away because this is like a different sort of a trajectory. But this is also something that can be done. Okay. Any other questions that you have at your end? This is fine. I think will you be? I hope you will be able to uh, take this example and try it out at your end. So feel free to try it out at your end and letting me know what sort of experience you had. Okay. Now coming back to the presentation. So I have some extra things also what you can also try out. So one also thing is that there are so many different models also that you can choose for transfer learning. So which one to use for your specific application? So that is something that that you can get from journals. So probably there are some links you can go through these journals and try to see what other experts are talking, domain experts are saying in this specific field. Okay. And then you also get an idea with how you can compare transfer learning with models pre-trained on different types of data. So this could also be interesting. So taking, let's say, a particular transfer learning model, if you train it on different types of data, what sort of results that you get? Okay. So I have a couple of links here for that. What more? So in this case, what we did was that we found one particular pre-trained model, which we use YAMNet directly here. So we found one directly here. But if you are looking for other sort of networks which are not directly you see in the deep network designer. So deep network designer has some, right? We saw it. Let me take this out. So let's say if you're working with any network and you don't see it listed here, then what do you do? So in those cases, what you do is that you try to use something known as an open neural network exchange format. So any non-MATLAB repository, you can actually install it. So if it is Cafe, PyTorch, you can use ONNX to import that model in MATLAB and then work with that particular model. That should be possible. Okay. If you're using TensorFlow, you can also directly introduce to MATLAB, Cafes, Keras, and Cafe TensorFlow. You can directly import. Any other you have to use via ONNX. Okay, so this is one thing we have to sort of keep in mind. I hope this is fine for all of you. Apart from that, I think the another important step that we typically have is the deployment part. So after you've created this model here, what you can do is that you can go for code generation. So if you are deploying it to a CPU, I think it's not much of a problem, right? If you're deploying it to, so you can generate code like C code, C++ code. To deploy it to GPU, you can generate CUDA code, or to deploy to FPGA, you can generate HDL code without explicitly going and coding in the native language. The way it works is that there are certain coder products which are there, which allow you to do this code generation automatically. Okay. So I will let you know where you find this code generation thing. So let's say I want to uh, generate code, C++ code. So in that case, I will again go to MATLAB. I will go to the specific add-ons, get add-on. So just look for this option called code generation. And you will see that there are many such uh, toolboxes that come up. So embedded coder is there. So if you want to generate embedded code, you will need embedded coder. It will generate C++ code, right, for embedded systems. So this could be code that can be that you need to, let's say, deploy to a Raspberry Pi. So this could be something that could be useful if you are working with any FPGAs. If you want to generate VHDL or Verilog code for FPGAs, you can use HDL coder. GPU coder is needed if you're working with NVIDIA GPUs or in instances where you need to generate GPU code, you will need GPU coder, right? So what it will do is that it will directly take your MATLAB code or your Simulink model and generate GPU code from it. Yeah. Any questions on this? I see there is something. Okay. Okay. What else? So in many instances, I'm not going to deploy code to a particular hardware, but it might be integrated with something that is there on the, let's say, cloud or any sort of cluster. So there are a couple of ways about it. Let's say I have developed an AI model. I want to deploy it as an app, which is accessible from anywhere in a network. Then I can use something known as a MATLAB web app server. So there is something known as a web app server that allows you to take a model and then convert it to a web app, which can be accessed over internet. So within an institution's network, you can access that particular model and run certain inferences. You can put some input, get some results. That should be possible. In case of any enterprise or those who have a particular IT infrastructure, there is also something known as MATLAB production server. So in the industries, they actually use MATLAB production server, and using that, they integrate the AI with the cloud infrastructure or the IT infrastructure they have at their end. Another popular workflow, which we actually have a lot of instances in the industries, is something known as model DevOps or MLOps. So in this case, we also have a workflow. So they allow you to integrate with the tools and IT systems on the cloud or on any edge platform. Okay. So we also integrate with that. So there is an entire workflow on this. So I'm not going into the details of that, but it's just good to know that this is also there. So if you are trying to take a particular code, you can integrate that particular code with frameworks like GitHub. Uh, you can integrate with different DevOps platform, right? Like Jenkins and all. So we have that, and also if there is a cloud computing resource that you have, So we can also integrate the model with the cloud computing platform also. So that part is also there. So there is an entire workflow around that. Okay. Now I will take one more example of a user story. So this is coming from a Japanese customer. So it's very interesting because what they have done is that their challenge was mainly deployment. Okay, so they were good. They had actually developed their AI model. So their AI model, they had actually used TensorFlow and Keras, but they were not directly able to deploy it from any other platform. So what they did was that they imported the model into MATLAB. Okay. After importing the model in MATLAB, they actually developed and deployed. So they actually developed a user interface. So in MATLAB, there is something known as an app designer. You can actually create user interfaces for your algorithm. So external users do not need to get into the details of your model. All they will do is that they will feed some data and they will try to see how your model actually works, how your app actually works, more like accessing the functionality of a particular app. So that is what Mitsui Chemicals did. They took MATLAB as a platform, imported the TensorFlow Keras model, which they had used previously, they had trained, and then they developed an application around that. They created a user interface which anyone can use, and then they were able to integrate it with the system they had at the back end. So this should also be possible. So this is to give you an idea for users who are using other frameworks. You can actually import it into MATLAB and use it as a deployment sort of a platform also. It should be possible. So overall, they were able to actually reduce the visual inspection time by around 80%, because in this case, from MATLAB, the code that is generated is efficient. There is traceability, and it also adheres to the different standards which are there in the industry. So in the industry, if you're working with automotive, we have to adhere to ISO 26262. So in that case, whatever code that is generated, it has to adhere to certain standards. So that should also be possible. So this is one instance where we can see why industry actually looks at MATLAB as a solution. All right. Any questions or comments on those? Have you encountered a situation where you had created a model and you found uh, so you have created some model and you found challenge in deployment? Have you faced this sort of an instance? Anybody? Chances are that you have created a model, but you had challenges in the deployment aspect of things. So we recently had a break. I hope people are a bit responsive now.
Participants, please respond.
Okay, I see. So thank you, Pooja ma'am, for your kind response. So you have not tried deploying a model. Okay. Anyone else try deploying any model? Deploying or building an app around that? I hope participants are not trying to deploy now. Okay. So the thing is that deployment is not easy. The reason being that you also have to probably know about a particular programming syntax, right? That is one thing. The other thing is also that in case of deployment, you do not any error. If you hand code it, if there is any error, it will be very difficult to find where that error is coming from, right? So in this case, uh, in case of MATLAB, there is very good traceability. So you can very easily trace where a particular uh, uh, code generation, that where that code is coming from. And thirdly, often it is not that you will be restricted to a single hardware. We have seen use cases where a particular person has worked on, let's say, a Raspberry Pi, and then they want to go to a Jetson Nano just to check out what sort of performance improvement they get. So when you are taking a same algorithm and trying to deploy to different platform, it's always good to have some sort of workflow which takes into account the flexibility of deploying to different platforms. So once you have something created in MATLAB, the algorithm you can very easily deploy to different other computing platforms or different other embedded systems. So this is one of the reason industries prefers this sort of like workflows. Okay. Okay. What else? So okay, this is what we have heard from them. So they actually were able to save a lot of time from implementation and development. Okay, so now I will be coming to the summary part of things. Okay. So today we covered two examples. In most cases, what we did was that we did a transfer learning with pre-trained AI model. We were trying to understand that when it comes to a particular model, what is the data-centric approach that I can use? So in case of a data-centric approach, we understood that feature extraction plays a very important role. Feature extraction is specifically when a particular person with knowledge of the domain create some certain features, or then there are tools that allows you to create certain features based on the signal data that you have. So that feature extraction, if you are able to do, it is possible to work with simpler and smaller AI models. And you can get very good sort of accuracy when you use this sort of an approach. Another part that we can actually think about is that when you have feature extraction, chances are that you don't need a lot of data. So you can actually work with less data sets, or if in some cases, if you need more data set, if you have some restriction, you can simulate and get data point also. So I remember there was an instance where there was a group working with some model, and they said that they were not getting any sort of real data sets to work with. So in that case, they were able to build a simulation model, and from simulation, they were able to generate data. Okay, so that should also be possible. So domain experts are best placed when you actually select certain features. So you need to actually look at what sort of models you can use to generate the features, and depending upon what sort of signals you have, chances are that you might have to go for different sort of features also. Okay. There are also tools. So there are tools that automatically allow you to identify certain features and select those features. So there are tools like wavelet scattering and also which allows you to select certain features. So that should be another way which is possible. And then after doing everything, if we are still looking at some accuracy, we can look at Experiment Manager as a platform where we can sort of look at how we can change hyperparameter and come up with better sort of models. So again, the emphasis on domain is on domain experts. So they are the best place when it comes to selecting certain features from the data that they have. Okay. So we have some resources also with respect to feature extraction. Again, I don't want to spend a lot of time on that. So if you are looking at more details with respect to how you can select different features, so please feel free to look at the resources that that we are sharing. So that would be giving you the more details. Okay. And whatever we talked about, this is not just an example to use. So if you need, you can modify the example and use it for your own application also. Okay. So we saw that how you can use a data set of air compressor to identify instances of any sort of faults in the air compressor. So companies like, if you see Daihatsu, so this is again a Japanese company, they were able to use AI to classify engine sounds. So based on what we have learned so far, the same sort of approach would also sort of work here, right? So they were actually developing an AI solution that can judge the level of engine knocking sound, which specifically only skilled workers could judge. So people from the domain could actually just hear the sound of an engine and tell whether it is in a proper condition or not. Even we do it, right? Even sometimes when we hear certain strange sounds in the engine, we know that it is the right time to take the car to servicing or show it to a mechanic. So AI can actually do that also. And in all chances, I think these are the areas where there are multiple companies also working with. So they were able to create classification model and very easy to use interfaces using MATLAB. And overall, using this approach, they were able to identify the knocking sound from engine as accurate as that of skilled workers. So they were able to perform knocking sound analysis, same sort of accuracy as that a skilled worker would do. So overall, using this sort of an workflow, they were able to increase the AI expertise through training. So the team that was there at Daihatsu took MATLAB training, and they were able to do this part. Also, just creating an AI algorithm might not be the best approach. We have to also think about how you can make how you can create an interface around that so that it's easier for users to actually interact with the algorithm. So you can create easy to use interface to interact with that algorithm. Same thing they also did. They promoted visualization of AI and increased the awareness of AI. So their comment was that although they tried other programming language, it was quite hard for them to implement it. So that's when they decided to use MATLAB because that allowed them to very easily to import the data. And then you saw already that it has a very intuitive interface that allows you to very interactively work with the different graphical component and create the algorithm at your end, right? So just to give you a complete picture, while we are talking about interface, so when you go to MATLAB, okay, we talked about these apps, right? The apps that we were using to do our task, like Deep Network Designer and all. So Daihatsu and all, they're also building interface which looks like these apps. The way you can go about it is to use this option called Design App. So this will open up an app designer interface where you can create a interface for your particular application. Okay. So I will just let you know that this is there. So here you can actually create plot, you can bring in data, you can have different buttons, you can have images, text, and everything, tables and everything. And at the back end, MATLAB will automatically create the code for you. All you need to do is that you just need to integrate your algorithm so that a user can actually interact with your algorithm, import some data, and then after doing at the back end, some sort of algorithm will run, and they should be able to visualize the output here. Okay. So this is something you can actually very easily build here. And after building, you can actually share it with others as a MATLAB app, which will be getting installed in MATLAB as a web app, which one can access via browser or as a standalone desktop app also. So I know like there are multiple industries which use this sort of workflow after developing their AI model. They build apps for that particular model also. All right. Any questions so far? Okay. Okay. All right. If there are any questions, any sort of questions, I would be happy to take. Otherwise, it will be me who will be speaking based on what I perceive. Okay. All right. So I will summarize now. So what we covered here, you can actually use transfer learning. So this is something that we found it's very feasible. It allows you to train very faster. You have access to the state of the art models which are there. You can import those models into MATLAB, do the training, saves a lot of time and effort. Feature extraction is a very important step that we found. With feature extraction, you can actually work with very simple models. Your data requirement goes down and you have very good accuracy. And in future, I expect like data-centric approach is going to play a very important role because you see, it is not just creating a model. So I can create a model using a very complicated network, but eventually in the very end, we need to deploy it also. So we need to look at the memory restrictions when we are creating this sort of model. A simpler model is always preferable. It's very easy to integrate. It's very easy to actually sort of deploy. So rather, I would come up with better data, identify better features from my data. So that's why feature extraction plays a very important role in the entire modeling process. right? This will lead to requiring smaller label data set. This is something that we also sort of understood as a takeaway, right? Yeah. So this actually multiplies the impact of data engineering, right? So data engineering is a very important part of what we are talking about. So I hope this sort of helped uh, give you some very takeaways from today's session. Also, like once we hear this thing that we are focusing a lot on data, so the next question that probably comes up is that how can I enhance the quality of my training signal data? We got some idea. We sort of got some idea based on what we did today. Spectrogram was one of the ways we did that. Okay. Apart from that, if I have data at my end and we want to build accurate data label, something that can help me is the signal labeler app. Again, there is an app. You can feed data to that particular app, identify your signal and identify the features in the signal, and automatically you can label those particular signals. So signal labeler app will allow you to save a lot of time, right? You don't need to manually go and label data. You can automate it. Automation saves a lot of time, and I have seen a lot of companies use this because they have very huge data sets. The other thing could be to record and label new data via apps and hardware. So we saw there is app designer. So if you have some data at your end, let's say you are creating some sort of video, why don't you create an app that takes a look at the video and maybe record and labels the data? So that should also be something that you can think of from your end. That is also something we see companies using at their end. You can synthesize data via simulation. There could be instances where it might not be possible to generate data in certain instances. Okay, so let's say there is a person with a certain sort of a disability and we need to generate the data, but probably we can take the help of simulations also. We can change a few parameters and try to see what sort of data we are getting. Okay, instead of just focusing uh, on the aspect of looking for data. If we do not have any data at my end and we really know, then we can actually generate synthetic data. So in case of MATLAB, we have Simulink as a platform where you can build different sort of systems. It could be a biomechanic system also, like what we see here, and you can generate some synthetic data. Finally, there are ways you can augment the data. So there is something known as audio data augmenter. We have a workflow for that. Using that biosignal processing, you can generate some audio data based on data that you have at your end. You might be having limited data. Based on this sort of a workflow, you can generate some augmented data. Okay. Yeah. So finally, I hope based on what we have learned, we will be able to unbegin AI. So we will be able to come up with a more simpler and more size-effective model, right? And definitely, MATLAB will help you. MATLAB and the entire suite of toolboxes that we have will sort of help you in this particular journey. Okay. Apart from that, just for those who are new to MATLAB probably, and you want to learn about how you can start learning about this sort of workflows, I will share a few resources. A really good place, a really helpful place to go about is on the self-paced platform. Okay. So I'll talk about this in a bit. Any questions so far or any sort of concern? I can take that and then I will cover a few learning resources and then we can end for question and answer.
Yeah, participants, do you have any other queries to Dev?
If not, then I will assume that everything you could totally understand. Yeah, you were perfectly able to understand what was covered. That is one takeaway for me, I would say.
You can unmute your mic and ask.
Yeah, please
Yeah.
feel free. Please feel free. And I say any question is a good question. So if you're working on anything and if you have any sort of questions, I would be happy to take a look at that.
Anyway, you will come across these things at any point of your research, I think so. So you can
Yeah,
have
yeah,
it
yeah.
look. Yeah.
So nowadays AI is like so in no matter whichever domain you are working with,
Yes.
AI is
Yeah.
a
Yeah.
part of
Anyway,
that now.
somewhere, we can be a part. Otherwise,
Exactly.
uh, moving with the trend in some parts of my our research, it will be good, I think so.
That's very correct.
Yeah.
So it's good to know from before what is there, but eventually when we work on a very specific problem, then we get into the details of what we really need. Okay, so that's a very good question. So any example of pharma companies? So I know there are certain pharma companies which whom with we are working on, specifically in the area of machine learning and AI. Yeah. So one example I had seen was in machine learning, there were pharma companies who manufacture tablets. And when this tablet sort of come out of the assembly line, they have sensors which sort of measure that which sort of pass a signal to measure that the product that is coming out is intact or is in proper form or not. So they do it by taking images or they do it by passing some sort of IR signal. And then they use machine learning and deep learning to identify whether the production system is running fine or not, if there is any fault in the product that is coming out or not. So apart from that, I will probably quickly take a look, but we have very good presence now in the pharma sector. So they are one of our, I would say, the growing users which you see. I will try to see if I can share some examples. So very good comment on that. So we have, okay, let me just quickly see. Yeah, I will just share what we have. Yeah. So this is slightly older, but this will give you some perspective. So I have a video from some of our some of our technical team who actually interacted with the pharma community. So in this video, they talk about what sort of AI approaches and mathematical model they use for pharma. Right. And then examples also, I think we have some now. We have an entire page talking about what are the things that are there in the pharma. So use cases and all we also have here. So maybe I'll just share the page and then probably I'll share the link also. So this is the page where we talk about how pharma uses our workflows. So process engineering is one of the places where they use MATLAB, of course. They We have something that allows you to model and simulate drug discovery and development. Okay. Then uh, medical devices is a very important area. So no matter what medical devices you are planning, you can use our workflow because medical devices, the code that you eventually deploy, it has to adhere to certain standards. Okay. So we have some use cases here talking about Gentech, Medviso, Battle, and then we have some examples also that you can try it at your hand, medical and health analysis data. So based on this data set, you can look at, you can understand how they work with the data set, how you can do data processing, how app-based workflows can be used to streamline analysis, scale, and then deploy schemes to the cloud. This is very important. This is what I see a lot. Okay. And then one of the aspect is also that when you are performing this sort of analysis, given that there is so much data, how you can parallelize the entire analysis process and then run those sort of instances in a high performance computing cluster, right? So we have some examples here. So predictive modeling for healthcare, uh, something in the area of medical imaging also, drug discovery and development also, we have some examples. Yeah. So yeah, please feel free to take a look at this. In the area of drug discovery and all, we also have something known as sim biology. Not my area of food, but I can, if you have any research problems, I can connect you with some of our experts in this particular area, right? So that's a very good question. Thanks for that. Anything else that you have? uh, or should I go to the resource part? Okay, so I will share resource. If you have any questions, feel free to post. Any sort of question is fine. So in case of MATLAB, we have many self-paced learning resources. The page you can access it is called as MATLAB Academy. Self-paced means you can take your own time to complete a course. So MATLAB Academy is the page. Uh, the good thing about this is that the whatever progress you have, it's self-paced and it gets saved when you actually do that. So if you're new to MATLAB, start with MATLAB on-ramp. It will have you some. It will have some tasks, some videos, and it will take you through the entire journey of learning MATLAB. And once you complete, you'll also get a course certificate, which you can share on different platforms. Specifically in the area of AI, we have a particular segment. So where you can see you can learn about machine learning, deep learning. There are introductory courses which are free for everyone, even without license. So there is machine learning on ramp, deep learning on ramp. And then there are in-depth courses like machine learning with MATLAB, deep learning with MATLAB. So machine learning with MATLAB itself is around 12 hours, right? It goes into the depth of all of it. Then there is deep learning with MATLAB. It goes into the depth of what is there. So I will just show you what is there. Talks about convolutional neural network, goes about understanding of convolutional neural network, what is there inside, how you can understand what are the filters, viewing activation of different layers, creating network, training from scratch, creating network architecture, understanding network training, validation, how you can take a particular network and improve the computation part of it, troubleshooting method. If you have some sort of challenges, how you can troubleshoot that, visualizing different network predictions, how you can augment data store. If you have less data, what to do about that, working with experiment manager, right? So it has everything in detail. Deep learning for computer vision, recurrent neural network. So these are also courses that you can take at your own time. Uh, but it will be a lot of benefit to you, like if you are able to complete that, right? What else is that? So this is I have checked. Yeah. So these are the courses. Okay. Apart from that, if you are faculties who are teaching courses, we have some ready-made content for you. So there is a place on MATLAB and Simulink which says courseware. Again, I will pass you the link to that. Okay, so this is the place where you can go looking for content. So if you are having a course, let's say on AI, so this is the place where you can look for content. So machine learning, deep learning, you can actually search for courses, and there are certain courses which are designed by faculties or MathWorks or folks from MathWorks team, and you can directly start using it in your content in your area. Okay. So let me search for something basic, like let's say mathematics. So any sort of courses, if you're looking for, this could be the place where you can actually look for content. Okay, MATLAB and Simulink courseware. Also, in the domain of AI, specifically, our team has also designed some courses. So that could be also something that you can take a look at. I will just give you a brief preview of that, if it is possible. Let me check. Meanwhile, if you have any questions, feel free to let me know. I can take a look at that also. Yeah. So I have a course here which says Introduction to Artificial Intelligence courseware. Let me add it to the path. So what this courseware is that it has, let's say you are teaching a particular course on AI, and if you want to use MATLAB, it has a very good starting sort of content that can be directly integrated to your particular course. Okay, so it has, like, let's say, let me just focus on deep learning. So it talks about what are CNN, what are CNN for images. Okay. So how you can load and explore data, some examples it goes through. So these are examples that you can directly use for a classroom. All the details are given, so it's very easy to incorporate. It also focuses a bit detailed about what is convolution, what happens when you do convolution, right? So what is a convolution filter, how it relates to image processing, understanding these filters, what is padding, and then some examples to understand what happens when you do a particular filter, what a particular filter sees when it runs across a particular image. Okay? So this course is as of now still not open. So if you want to have access to this particular course, please feel free to reach out to me. I will sort of post my email ID also
Ma'am,
in the chat.
sir, one more comment
Yeah,
is there from Shubha ma'am.
yeah.
Uh, about sim
Okay.
biology. Yeah.
So thank you, Shubhalakshmi ma'am. I will just put my email ID. So I will connect you with someone with XP with who actually looks at this particular domain. So they will be able to help you out with the problem that you are working on. So I can create a meeting. Just drop me a very small email. I get what you are working on. Just drop me a very just drop me an email with whatever you have written here. I will get back to you. I will create a meeting instance, and then we can meet one of our experts with expertise in this area. Okay. Also, if you want to if you want to try out the course that you just saw, if you're teaching a course on AI, I'll be happy to share the course with you and also take you across what we have as content. So that should also be possible. Yeah. So it's 12:30. I will. It's been a long time. So thank you for your attention.
Yeah.
It
Yeah.
was really good. It was really interactive, and I hope you found some useful takeaways from today's session.
Yes, I think
Feel
so.
free.
I do think
Yeah.
so. Actually. Yeah. Yeah. Actually. Yeah. It was a great insightful session, sir. Actually. Thank you for spending a lot of time with us. For our because this is our final day of international workshop, so it will be ended quite magnificently. It will be good. I feel so. You justify that. I think so. So on behalf of Amrita School of AI and Amrita Vishwavidya Pedam, on behalf of me also. So thank you for coming for a humble platform. So thanks a lot, sir. Uh, and as per the coordinators itself, I thank you for your great session on MathWorks MATLAB training and all. So
Yeah,
I
thank you for
think
this
it.
opportunity, sir, for allowing
Yeah,
us. And it was really nice to interact, I believe. And uh, I hope all of you found some useful takeaways.
yeah,
So I will say that often just looking at things is not easy. Probably if you are new, you need to try it out. So I will share my presentation with sir. Feel free to look at the links and try out the example. If you have anything, you can write back to me.
sure, sir. Thank you. Thanks a lot.
Thank you. Yeah.
Thank you for participants. We will again meet up after 2 o'clock. So 2 p.m. there will be a session for transformers and in computer vision by Dr. Soumya V. So that's our final end session. So uh, yeah, and after that you just hold on 4 to 4:30. I want your feedback on open feedback from all of you. I will give the feedback form also in 4 to 4:30 time. So fill it and just give us open feedback in the validatory session at that time. So thank you all. Thank you. Bye. Thank you, Dev sir. Thank you.
Yeah. Thank you, everyone. Have a good day.